how this is going to work again. There's a bracket. We've got 10 competitors. How much time, what's the integral look like, and so forth?
Yeah, so basically we'll have the bottom 4 seeds face off at first to cut the 10 down to 8, and then it'll be a standard tournament elimination style contest. The rounds will be first to 2, except for the finals, which will be first to 3. The integrals will be given in the forms of medium, easy, and extreme. So they will actually have different time limits based on our perceived difficulty of each integral. The time limits, I believe, are 3, 4, and 5 minutes for easy, medium, and extreme, respectively.
I'm guessing the example on the screen, we have the integral of 1 dx is about as easy as it gets in this competition.
Yeah, I don't suppose we're going to see too many more like that. That might get a T for trivial, but aside from that...
My fear is that's the only one I'll be able to do. What kind of form are these in? Are they all indefinite? Are there definite integrals?
There's a healthy mix, I'd say. We have some indefinite integrals that we just want them to integrate straight up without any worries about constants or anything like that. We also have some definite integrals, and usually we made an integral definite because the limits actually make the integral possible to solve in some cases or much easier to solve in other cases. So generally, if an integral is definite, it is for a reason, although that may not always be the case.
So the part I liked in the rules is that the 2 guys start. When someone circles an answer, everybody stops, puts down the chalk, the clock stops. If they're right, they win that round. But if they're wrong, then the other person gets to resume their work, the clock resumes, and they have whatever's left on the clock to finish their answer. Of course, that whole time, they get to think, they get to listen to the exchange with the judges, they get to look at the other guy's solution. I mean, it's important to be correct, but it's also important to be fast.
Exactly. We place a premium on accuracy, even though this is somewhat of a speed competition. This year, we believe that the difficulty of the integrals will lead it to be more of a speed more than a skill and speed competition, because from what I've heard from the contestants, last year was truly just a speed competition of whoever could evaluate easy integrals as fast as possible. But this year, the integrals really will not be that easy, and I hope the audience can figure out some of them on their own so that they can really appreciate how tough it is for these guys to be up here on a stage working them out in front of everyone.
So we can expect some 3 or 4 minute rounds that end in stalemate. Nobody gets the answer. You just move on to the next integral.
Personally, I certainly expect it. I would be very surprised if it wasn't going to happen like that, but then again, who am I to say how good these kids really are?
That's true, and we've got 10 of them here, and they are likely to be formidable competition. Here's how this will work. During the integral, you'll see it on your screen. You'll also see each of the competitors. There's 2 cameras on the left and on the right. Each of those will be focused on that particular individual performing their integration. You'll be able to follow either integration, or if you prefer, you can work on the integral yourself. Albert and I will give some commentary. If you're trying to avoid any sort of hint, you might want to turn the sound off during the integral round, and then between rounds, we'll discuss things quickly, see where things size up, and we might throw it down to Alice for a couple of quick interviews with some of the competitors as they leave the stage. It looks like Ross is announcing that there'll be prizes for the first, second, and third competition, just finishing up with the rules. And I think, as can be expected, the audience needs to be quite cooperative here so as to disturb the fairness of the competition. Not a bad crowd here tonight. There's got to be at least 60, 70 people, more coming in by the minute. 54-100 is not a small room, and we're filling up a good chunk of it here tonight. Yep, there's more folks coming in. We're in the back of the room, up in the broadcast booth, so we have a nice view of how this all lays out. Anything else we want to be looking for, how this might go?
I'm actually quite curious to see how the other competitors react while they're watching the 2 people up at the board. Because first of all, I'm sure they'll be thinking, I wonder what would have happened if I got this integral. But they're probably also just curious as to see how well the other people do, whether they've been eliminated at that time or not. Certainly, I'm interested, and I'm sure as just mathematicians, they'll be quite interested as well.
It's kind of like the spelling bee, where you see all the kids with these looks of chagrin. They've lost, but they know they would have gotten that word or this word.
Exactly. It'll be real curious. Hopefully we'll get some animated characters down there.
Are the competitors in that front row? Is that the 10 of them?
It looks like those are the 10 competitors, yes.
So we've got a front row of exactly 10 seats, 10 folks down there, all eager to go, I think. Just wrapping up a few final details. We'll be back in just a moment. This is Sportcast at MIT.
This gives you any advantage or anything. All right. If the person who's presenting
So
has
we can
circled
put
and doesn't stop,
divisions
and
in
marks
here.
that minus sign after Sid has said
Probably help us
stop,
too, not
then we'll consider that a
this whole time.
disqualification
Yeah,
for,
no
for
cough
the round.
switches. Like you gotta
Yeah.
You just eliminate it. All right. Now, the person over here who's, contesting, well, they might be in the middle of a thought or something like that. And maybe, they're lost. Since I stopped, they hardly even hear him because they're so, engrossed. Well, they should really stop. All right. But if you screw up, then you only forfeit the phase, which means that integral will go to the presenting person. All right. Which means you won't lose the round. You won't forfeit. And I think that's kind of fair because it's really the harshest punishment should be to the person who is presenting and then corrects it in the middle, which is just weird.
So the person who circles and then corrects, they automatically forfeit the entire
If you circle
and correct.
and Sid hasn't said stop yet, and you put a minus sign, then fine. If you circle, Sid says stop, and then you put the minus sign, that's it. You're gone. Okay?
Thanks.
Okay. But and thanks for the question. Are there any other questions, especially from our contestants here?
Campus of Massachusetts Institute
All
of
right. Well,
Technology.
let's get started. I
2006
believe our
MIT
first round
Integration B.
is
There are
between
10
Ross Fu
contestants.
and Lee
We're
Yu.
ready to go here with the first round. And our two contestants are coming up. Let's see, there's a handshake. Yes, there's a handshake. Here we go. The match is on, as they say.
Junior.
All right, here we have Ross Fu and Li Yu. Both of these guys did quite well in the preliminary exam, of course, to be here. I want to note to the audience, if they think there's something strange about the bracketing, it's actually that 8th place, 9th place, and 10th place all actually got the same score, and they were assigned an order more based on what integrals they solved correctly and things like that. So that's the reason why first place will be facing the winner of 8
Some of
and
these chalks need a little bit of
9, because
breaking in. So
that
just make sure
guarantees
you're
that the
okay.
first seed will face one of the 3 people with the lowest score in the preliminary exam, whereas second place has a possibility of facing the 7th seed, Ross Fu, who did score a little bit better than 8 and 9.
So we've got Ross Fu on the right. We've got Li Yu on the left. A little bit of practice with the chalk. Make sure they're comfortable with the feel of the chalk. It's the big fat kind of chalk we use for big lectures, so it's not necessarily the most familiar medium to do integration in, but I think they'll do well. Some joking about them solving that integral of 1.
Yeah, it'll be really interesting to see how these kids react to having to write all their stuff on a big board. I'm sure it's not something they're all used to. Fortunately, at least we didn't have any chalk allergies or anything like that to deal with. It's already going to be bad enough to have to write in hopefully semi-big writing and really just a stage that's just not comfortable at all relative to working at a desk like they're used to.
Kind of like that.
Let's see. Ross is showing us a couple examples. That was a definite integral that flashed by just briefly.
Yeah, be sure that you can see,
0 to pi of 1.
that's basically what those integrals are there, to make sure you can see
I think
I
both
think
of the
he's showing the
contestants.
simplified form they're expected
Yeah.
to give their answers in.
All right, are we ready?
So we've got Li Yu, number 10, on the left. Ross Fu, number 7, on the right. The audience is ready to go. The contestants are ready to go. There are 3 minutes on the clock. Welcome to the opening round of the MIT Integration B.
All of these integrals will be easy, at least relatively speaking.
And we have our first integral up on the screen as the clock starts.
We've got the square root of the quantity x over 1 minus x cubed, and this was indeed labeled as easy, although I don't believe it's immediately obvious how to do this, although both contestants have already started working.
Ross Fu on the right erased his work and started from a fresh board. He does have a second board behind this one if he wants to use more space.
Ross looks to be using some sort of u substitution here, as I can see a little u equals x cubed,
Yep.
x equals u to the 1/3, and looks like he's trying to figure out exactly which to substitute for which. Sometimes contestants may want to substitute something in for x, in which case the dx really is going to play a big role, and other times they're going to do the traditional u substitution that I'm sure many of our viewers are familiar with from their calculus classes.
Looks like Ross has moved to 1 minus u cubed. Another fresh board. Li Yu thinking, a little bit of writing. Smaller and smaller as he crosses the 2-minute mark. 1 minute 50 seconds remaining in this first round.
It looks like Li Yu multiplied top and bottom by the square root of 1 plus x cubed, trying to make the denominator into something a little nicer. Because first of all, that's somewhat akin to multiplying a plus b by a minus b to get a squared minus b squared. And in this case, since there was a square root in the denominator, that does make the denominator noticeably simpler to work with. At least in his opinion, it seems that's what he wants to do.
Just under a minute 30 remain. Looks like neither competitor is at the point where they're ready to give a solution. They're both thinking through the problem. Li Yu in particular shaking his head a little bit, taking another look at the original problem he wrote on the board.
Wow, this certainly seems intense. Both guys seem to be at least a little bit surprised by the difficulty of this very first integral. I think that we should all keep in mind that on the preliminary exam, there were 30 problems and they were only given 20 minutes, so it was really a matter of hopping around and finding integrals you could do, whereas here they are forced to do the integral they have been presented with, and I'm sure that changes things quite a bit.
And with 42 seconds remaining, Ross Fu erases the board. That can't be a good sign for the competitor on the right. Li Yu still working.
Really
looks like he has a sense of purpose, but it's hard to tell if there's going to be an answer. 30 seconds remain here in the first round.
Yeah, it's really going to be up to Li at this point.
And Li Yu moves to board number 2. Now, is there any kind of partial credit? If neither of them gets it, it's as if no work was done, right?
Exactly. There is no partial credit. One of the reasons for that is it really would be hard to piece together what exactly would constitute partial credit. It would take time that we probably don't have, and also it would really be open to debate in many ways, since I'm sure both of the contestants had at least something that would lead to a solution at least somewhere down the road. After all, both guys do know what they're doing.
The clock has expired, and for the last 10 seconds, both gentlemen just stood and stared at the projection on the screen.
Audience gives them a nice hand. I think they realized it wasn't that easy either. The answer, yeah, 2/3 arc sine of x to the 3/2. The bottom with its third power instead of its second power, similar to the integral of sine, except certain things had to be done due to the fact that it was a third power instead of a second power, because normally the integral of sine has a square root of 1 minus x squared down there. And this, I guess, was enough to stump these guys, at least for now.
A little bit of friendly banter between the contestants. So we're going to move to the second integral, is that right?
Yeah, I think we'll just be moving on pretty soon.
So we're still best to 2, first to 2 wins.
First to 2.
And we'll move to the second easy integral, and here it is. The second integral is on the screen. The clock is running.
All right, well, this actually looks quite similar to the first integral, which is pretty interesting, except audience members will notice subtle differences. There isn't a square root over the whole thing. We have x to the negative 1/2 on top. It'll be interesting to see why it was placed like that and how that might affect some of the contestants' decisions in terms of how to approach this, because normally you don't really see a negative power in the numerator because it really just naturally floats down to the bottom. But I'm sure that's not what the problem writer had in mind.
So the presence of x to the minus 1/2 upstairs is a hint to the structure of how we might want to solve this problem?
Yes, it may either be a hint or it may be an attempted deterrent to solving the problem.
I see.
Yeah, you really can't tell just immediately. These problems are not easy, and I think that everybody's already kind of realized that from this first so-called easy integral that neither of our contestants was able to get in the 3-minute time period.
So both of these fellows have written more this time. Ross got through a lot, but then kind of shrugs his hands, and I'm not sure if he's happy with where he's wound up. He's got an expansion with u to the
u equals x to the 1/3 here. Ross has tried to make some sort of substitution work immediately both times now, and he hasn't been met with much success, at least thus far.
Li Yu a little bit more deliberate, but he now feels as if he's got, let's see what he's doing.
These guys got 1:30 left to go. We'll see if one of them is able to pull this one out. It looks like Li Yu has some significant progress here. Or perhaps he doesn't. He has some sort of partial fraction-ish thing. At least that's what it looks like from here. He has coefficients in front of 3 different terms. One of them u cubed plus u, another u squared plus 1, the other one u cubed plus 1 times u squared. And I'm not sure if it doesn't look like he exactly set up some sort of partial fraction necessarily, but he may be looking to do something with undetermined coefficients, a technique that maybe 1803 students will be familiar with, as that's a technique that in differential equations is often used, where you simply just effectively are trying to guess a solution and plugging it in to see if it's going to come out to what you want it to be.
So for our viewers that aren't from MIT, there are several MIT courses that correspond to some of what we're seeing here. 1801, the first calculus course all MIT students required to take. That's single variable calculus. Everything we see here this evening, in theory, solvable with what you learn in 1801. 1802, multivariable calculus, some of the more double integrals and so forth, things with multiple variables, things that relate to line integrals and such in the physics courses at MIT. And then 1803 as we cross the 10-second mark. Both competitors working furiously, but I'm not sure we're going to get to a we have a circle.
There's a circle.
With 5 seconds left, we have a solution on the left. Lee Yu.
Lee Yu has an answer of -1 over, I believe that's x to the 1/6 minus the inverse tangent of x to the 1/6, and I don't think that's right. He's shaking his head.
So this could be an advantage, because if Ross can figure it out fast enough, I mean, admittedly with 3 seconds left, it's hard to get much down, but he's certainly thinking through it. The clock has restarted, and neither competitor gets it.
This will, again, end up as a draw.
4-minute timer. Okay, is that all right with you guys? Yeah, sure.
So it looks like there's an on-the-fly rules change of some sort. I'm not sure what Ross is proposing here.
I believe he proposed to extend the timer to 4 minutes, even for easy integrals.
I see.
And with at least the outcome so far, that might be the right decision. And it looks
Oh
like...
boy, he was close. Oh boy, he's hitting himself. Lee Yu had it. He had the
really
relevant
had it.
piece of the integral.
Simply... And that's what's tough about this competition. I mean, he figured out an integral that I think most of the audience members and most of our viewers would agree is a pretty hard integral. And he's able to get it down pretty much entirely to where it should have been, except he's just made a small mistake. And that's another part of this competition that we have to keep in mind. I mean, this isn't just sitting down at your desk comfortably with as much time as you want. There's a lot of pressure, there's a lot of potential for silly mistakes, and I believe we're going to see more of those tonight.
Yeah, small mistakes crash rockets into planets, though, so it's important to get the factor in front right, just as much as it is to get those complicated terms.
Exactly.
So just to finish that thought, and then 1803 is differential equations at MIT, not a required course, but many of the engineering majors require it as part of the major. And certainly some of the concepts from 1803 can carry over as well. So we're off. Third attempt now for both of these gentlemen. The clock has started. We have our third integral on the screen. Some hyperbolics in this integral.
I think that if at least one of the two contestants knows his hyperbolic trigonometric functions, he'll be able to get this problem. It's really not too bad if you've got the relations between cosh and sinh down. If you don't, I think they're going to be in a little bit of trouble.
Lee Yu looked like he had it, but then he's backed off. He definitely has some action going on.
Yeah, he definitely has an idea of what to do. Ross, on the other hand, hasn't written down anything. I think he might just be trying to remember what cosh and sinh exactly do and what their relation is. I believe most of our viewers will probably be familiar with the with sine squared plus cosine squared equals 1. Cosh and sinh have a similar relation, which I won't mention out loud here on the air. But whether or not that even helps them solve the problem, I'm not even sure.
Well, 2 minutes now remain. And Lee Yu, who I thought got off to a solid start, has stalled. Looks like he's ended with the hyperbolic cosecant as the integrand, but up now he's moving again.
It looked like he might have. It seems that he did some sort of integration by parts, or at least tried to, and we'll see if that pans out for him.
Now, are the contestants allowed to look at each other? Is that sort of a faux pas? Is it explicitly against the rules?
I don't think they're really supposed to be trying to look at each other's boards, although if you consider the angle that they're at, it's really not going to be that easy for starters. And I'm sure the judges will enforce some sort of measures to prevent them from doing so if they feel that it actually is going to affect the integrity and just the overall spirit of this competition.
Sure. Approaching a 1 minute mark here. This is the third round. Neither competitor thus far able to get the integral, though Lee Yu so close on the second attempt, just off by a constant factor in front, a multiple can. Let's see, he's got... It seems that he likes to juggle a lot in his head. He'll write a few things down and then he'll think for a while. It's almost as if he's diagramming something.
Yeah, that's definitely a style thing. You'll see different styles from all the contestants here. I think that many may have noticed that Ross Fu doesn't like to write too much until he really thinks he's got something going. At least the first 2 times he tried to use substitution, erased it, and ended up standing there and really thinking for a long time. And this time, he once again didn't write too much for starters. And now we've only got 30 seconds left. And I think that part of the toll of simply just not getting the first two integrals is wearing someone on these guys. There might be a little psychological impact there, which is the least of their, really the worst thing that could happen to them at this point when they're already struggling with some of these integrals.
10 seconds remain. I gotta say, it cannot be pleasant to stand up in front of a room full of MIT students, including fellas seated 1 through 7, and not be able to get 3 integrals consecutively, but that in fact is what has happened for the 3rd consecutive round. Neither competitor, oh, well, let's see, Li Yu circled something. I think he came after the clock, but you wonder if the judges will be generous. Also don't know that it's correct, of course.
He may have just done it out of desperation, at least that's the impression I got. But let's see what the answer is.
Look, I totally guessed.
Yeah, you totally guessed, and he guessed wrong.
Yeah, I did get one turn, didn't I?
This wasn't the most unreasonable integral. At the same time, just the very presence of a hyperbolic right there probably threw the contestants off a little bit, because it's really not something you see every day, regardless of whether you're a math major or not. I mean, those are special functions that appear a lot in some places and just don't appear at all in many other places.
Okay, so the contestants are erasing the board. We're still stalled 0-0. First round, this is seed number 7 versus seed number 10. Li Yu, number 10 on the left. Ross Fu, number 7 on the right. Li Yu finishing his erasing of the board. Ross, of course, hasn't used quite as much of the blackboard, but it's still 0-0, so who's to say?
I'm curious as to whether or not there will be rule changes here tonight based on the fact that certainly this first round has taken longer than I think the judges and the organizers expected.
So this is a 4-minute problem. I don't know if it's a medium integral or if it's an easy integral with just more time. The integral's on the screen. The contestants are working.
You've got the integral of e to the inverse cosine of x. Very interesting. It looks like something where you either are going to be able to hit it right off or just be stuck there, because it's very compact and yet it involves some pretty complicated functions. We've got an inverse cosine in the exponent here, which cannot be pleasant to look at.
Ross Fu took off quickly, stalled for a second, resumed his work. He's again working with the substitution. Li Yu a little bit. I'm sorry, go ahead.
Looks like he is getting it now. He realized that the substitution is basically to stick in something along the lines of x equals cosine u, which is a very nice move, because if you take dx, where x equals cosine u, you're only going to get something simple such as negative sine u du. And now it's in a form that I think he's much more familiar with. We have e to the u sine of u right now.
I think Ross can smell it. He's working quickly.
He's still got a good
factors around.
Yeah, he's still got a good more than 2.5 minutes left. He's in very good shape. I would be surprised if he got this wrong for any reason other than a silly mistake now. He's still got to remember to plug x back in for u in the proper form, so I hope that that's not what ends up affecting him. But here it looks like, yeah, it does look like he has it.
Li Yu just froze at the board for a good 30 seconds. He's, well, let's see. Let's just watch the competitors for a minute and see what they do. Ross Fu has stalled a little bit. Ooh, that's not a pleasant look. Ross Fu on the right had the right substitution, or at least was working in the right direction.
He certainly has the right substitution, but even e to the x sine x as an integral is not a trivial integral. It's something that I'm not sure exactly what the best way to approach it is. I think undetermined coefficients actually is a relatively quick and efficient way to get to that, but I might just be mistaking that for something like x e to the x or something else. I mean, just these are not easy integrals even after he made the proper substitution. At least I'm almost certain that is what the writer of this problem had in mind, because
tell me a little bit about the integrals. These were, you folks developed these?
Yeah, we actually wrote most of these ourselves. Some of them we might have had a little inspiration from books here and there, but in general these integrals were written by ourselves. It's not too hard to write a complicated integral, but it is quite a bit harder to write a complicated integral that can actually be solved.
Sure.
And that is what it really came down to. Some of these integrals really just come down to a nice substitution like what has happened here, but even then it doesn't necessarily make it too much easier. It doesn't look like our contestant on the left here really has anything going at all.
No, he's made a couple of scribbles, but those were in the first minute and not much since then. 1 minute left in this round. This is the 4th round now between these two gentlemen. Thus far, neither have been able to get a point.
Sorry, the idea of x equals cosine u of some sort really has just eluded him completely, and without that, it doesn't look like he has much of a chance to get this. On the other hand, I'm really surprised that the clock has gotten as far down as it has, but perhaps that is just a result of being up there, working at a blackboard, just not quite the same as sitting there at your desk.
Now, Ross Fu literally ran out of board space and stopped. He stopped at the bottom right of that first board. Everything looked great, and he has not moved an inch beyond that point. 20 seconds now remain. Round 4, and it looks like we're going to have yet another push. So a defensive struggle of sorts to start the tournament.
I'm not sure if they might want to. I'm not sure if they might want to change it eventually so that whoever gets one first is going to just move on. At a certain point, that would be the reasonable move. Although right now it's still only been 4 rounds, and it would be fair to give them some more opportunities.
Let's listen to the contestants here with their take on the situation.
You almost had it.
Yeah.
There's the answer, folks.
That's right.
That's right.
That's
but
right there.
It's just integral video use on you did wrong.
They're remarking how I believe it's Ross who had it and really just wasn't able to seal it off. There's a lot of "you had it" comments coming from both the audience and the organizers here. That's really got to be a tough pill to swallow right now. I'm sure he would have loved to get a point here. I'm sure both of these guys aren't exactly just competing to move on. I think there's a little pride involved now at this point when they've been unable to solve the first 4 integrals that they've seen, all of which were at least theoretically marked easy, which may not bode well for all of the contestants in the long run.
Yeah, you wonder if Sriram Krishnan seeded 1, Vijay Kumar seeded 2, if they're itching to get up there and do some real damage, or if they're terrified at how hard the easy ones are. So
Both
the
of-
5th integral,
One
Ross Fu
minus-
very quickly off to a start.
1 minus sine x over 1 plus sine x. I'm willing to vouch that both guys will get this integral.
So this is a speed
Yeah,
contest.
I definitely believe both guys will get this integral.
We've got a secant squared on Ross's board.
There's a lot of things you can do here. One of them would be to multiply both top and bottom by 1 minus sine x. The old multiply by 1 trick
And
that I'm
that's
sure.
Ross's approach.
Yeah, I'm sure all of the audience members remember that from back in like algebra and other classes. And that gets you a nice 1 minus sine squared in the bottom, which turns into a cosine squared, at which point you're in business now, because you've got a good secant squared minus tangent squared, both of which I think are fairly reasonable integrals. On the other hand, there's other techniques you can do as well. It looks like Li Yu has just split it up a bit. I think he's split it into something like, I think he's split it into 1 minus 2 over 1 plus sine x, which also seems like it might be a good move, because now you've got a nice
We have
1.
an answer.
Oh,
I'm
we
sorry,
do have an
Albert.
answer.
We have an answer.
We
Li
have
Yu
an
on the left has circled an answer,
Fudge!
and Li Yu has it. No?
No.
No, he made an error. Seems like Ross Fu's in the commanding position now because he had his trigonometry
Restart the clock.
moving forward. He still has just under 3 minutes to go. Oh, look at what he did wrong. And so Ross is going to proceed. Let's see if he finishes up.
Ross
Excuse me.
should finish this one off. I would hope he does for... Well, I was a little bit... Well, he does have the tangent squared I mentioned earlier, but he does not seem to know how to evaluate that. And yeah, I'm sure not everybody knows tangent squared's integral right off the top of their head, although the best way to go at that one would probably be to make some sort of substitution, since sine and cosine are very related in terms of their derivatives.
Yeah, he got so far.
So far, so
multiplied
good,
by 1
yeah.
minus sine x, brought everything into the top, and then he's stymied. How did Li Yu work this problem? I don't see any trigonometry on his board.
It basically comes down to Li Yu splitting it into, like I mentioned earlier, the 1 minus 2 over 1 plus sine x. Because what happens there is if you just put all of that onto one denominator, you get 1 plus sine x minus 2. Oh no, it has to go the other way around. I'm sorry, negative 1, because then you're able to just get the original expression again. And it's a lot nicer to not have to deal with a trigonometric function in both the top and the bottom of an integral at the same time. So I'm sure that's what he had in mind.
Sure.
But unfortunately, it did not completely work out for him, and We're down to a minute here, so if Ross isn't able to figure out how to integrate tangent squared, we're going to go to yet another round without any results.
So I should mention to our viewers that for the first few rounds, we actually had the cables crossed, so to speak. And when we referred to the left, we meant the right. When we referred to the right, we meant the left. I'm not sure when that was corrected, but Lee Yu, the competitor now on the left of your screen, is the gentleman who's always been on the left of our room. And Ross Fu on the right, the gentleman working. Lee Yu got this one wrong. He's circled several answers now, been wrong both times. A silly error the first time.
Probably a
And
silly
a silly error
once
this
again.
time, I think.
Probably.
Yeah. So he is 0 for 4, so
Down
to
to-
speak. Ross Fu,
Down to 30 seconds
with,
here.
with just a few seconds left, looks to be the same.
It doesn't look like he's going to be able to figure this one out. It really can't be too easy to figure out how to do an integral in as simple of a form as, say, tangent squared, if you don't remember how to do it already. Because such simple things, there's really not too much you can do other than the standard way of how to do them. And yeah, time is about to run out, and it looks like going to another round.
He doesn't have it done. I see a natural log of some trigonometry. Hard to read that frantic writing at the end. Now, you mentioned that absolutes aren't required
No, they're
for
not.
natural logs, so there's the answer.
There wasn't too much to it. There really wasn't too much to it. As you can see, as the audience members can see, there are 3 terms there, and I believe each of them correspond to one of the 3 terms that you effectively got on the top in the numerator once you expand 1 minus sine of x quantity squared.
So apologies for not knowing our left hand from our right hand, but here we are. We're back in business. Round 5 about to begin. Neither contestant thus far have been able to make any headway against these integrals, all of which we have categorized as easy. Makes you wonder what's coming in the second hour of the competition. Makes you wonder if there is a second hour of the competition if these gentlemen don't get off the stage.
Yeah, I'm really a little bit surprised that there hasn't been at least one correct answer so far, although I do believe silly mistakes and unfortunate obstacles such as just forgetting how to integrate tan squared has really prevented these guys from getting some of these.
So we're off round 5. Clock has started. This is a definite integral from 0 to pi over 4.
We've got sine of x, cosine of 2x, and I've really got to believe both guys are able to at least do this integral. It's going to come down to who can do it faster, in my opinion. There's a lot of approaches you can take here. When you see a sine and a cosine, you're immediately thinking about substitutions and what you can do. And now that you see a cosine 2x, you're probably thinking, well, should I use the cosine squared minus sine squared form of that? Should I use 2 cosine squared minus 1? Should I use 1 minus 2 sine squared? Which of these is going to help me the most? And personally, I would suspect that you'd want to use 1 minus 2 sine squared of x, simply because that would bring the integral into a form where all it has is sines, although you will have to deal with the sine cubed at that point. But there's
Sort
probably...
of pick your poison in a sense.
Exactly. You're going to have to pick your poison here.
3 minutes remain. 1 minute expired. Round 5. Ross Fu on the right, Lee Yu on the left. 10 versus 7. Neither thus far able to get one of these integrals. Looking to take a commanding 1-0 lead at this point.
Looks like Lee Yu's got a lot going for him here. He's already evaluated an integral. I think he's just checking his work at this point. Probably the unfortunate feeling from having made some mistakes earlier is causing him to really look at this one twice. But he has many of the things, he has it in a form somewhat similar to what I was thinking about earlier, so it leads me to believe he's at least on the right
He
track.
changed a sign. He just changed a plus to a minus. He's going to carry that all the way through here. Let's see what happens.
And we've got the, it looks like the sine squared minus
We got
cosine
Ross
squared.
Fu has circled 1/3. Ross Fu has circled an answer. 2 minutes, 12 seconds remain. Oh, Lee Yu doesn't look happy.
It looks like he circled 1/3.
I have 2 minutes.
Okay, so 1/3 is incorrect. The clock has restarted. Lee Yu very excited.
Exclaiming his pleasure over having 2 whole minutes to do what he wants.
Seems all he has to do is carry that sign error through if that was the problem, but you wonder if just the pressure of 0 for 4 is getting to him a little bit.
it's really easy to freeze up there. I mean, if you think about it, we can all do 2 + 2, 5 times 6, those kinds of things. But sometimes when you're up there and a lot of people are watching, it just doesn't quite come to you, and all of a sudden you're panicking because you know it's something you should have instantly. And that's really a feeling you just don't like having.
I have to say this is an odd style. I mean, he writes out answers and then just selectively erase the numerator and the denominator of 2 different fractions.
He's getting a little encouragement there. Take your time from the audience. I think everybody wants to see a correct answer at this point.
Minute 20 left. Li Yu, the only man alive in this round. Ross Fu tried 1/3, isn't correct. Some trigonometry makes an appearance on Li Yu's board. Kind of playing the room, if nothing else.
I would almost suspect some sort of symmetry argument would also be viable in a problem like this, because it is going from 0 to pi/4. So
Sure.
you've got this chunk halfway to pi/2, which of course is quite significant when it comes to sines and cosines. The cosine is actually going from 0 to pi/2 if you look at the 2x inside. So I really wonder what exactly is going to happen here, because, well, sine of x goes from pretty much 0 to √2/2 over that interval, and maybe there is some way to set up some sort of clever symmetry trick, although what exactly you would do eludes me at this point.
Boy, I don't know. It's 25 seconds left. Li Yu did some theorizing on an auxiliary board, but he's back to his primary workspace, and with 15 seconds left, I gotta say, I'm not so sure we're gonna get an answer out of
Doesn't
this.
look good again, and I'm really surprised. This wasn't too bad of an integral, I'd say. At least the first steps, there's multiple possible first steps. And
He
we do have an
circled his
answer.
answer. You wonder if he was just checking and checking, but he's wrong.
He is wrong.
That was close, though.
Close, but no cigar, apparently. √2/3 minus 1/3. He had -1/3
Minus
minus
√2/12.
Yeah, he erased the wrong denominator.
Yeah, he took out the wrong denominator there.
Okay, I think we have a rules change. We're going to do a first to get an integral. We'll move on.
And that is the move I would make at this point, too, because this has gone on for quite a while. We might even run out of integrals if this continues over the next several rounds.
We're going to run out of integrals if we don't start changing things.
And
Ross echoes the concern.
Still don't realize why I did wrong, but oh well.
Both guys are voicing their concern over their own silly mistakes. One of them mentioning that he doesn't even know where he really got it wrong, thinking that he had it, and I'm sure he was at least somewhat sure of what he was doing up there. Both guys look like they had a pretty good idea of what was going on for that integral.
What
which is
happens
really
if
too
we
bad.
do run out of integrals?
I doubt that will happen. There is a significant excess of integrals. Basically, I think that if this happened every single time, we might run out of integrals, but odds are it won't. And I think at a certain point, the organizers will notice that there's not enough integrals left to go around, and the rules will just have to change. There's really nothing else you can do.
Okay, we've got our integral up on the screen. 4 minutes. Another definite integral from 0 to pi²/4.
I believe that limit is simply to make the answer a little bit nicer. I can't really think of any other reason they'd want to throw a pi²/4 in there. As for sine of square root of x, comes down to who remembers how to handle that, I suppose. I think letting x equal u² probably has some benefit to it, since then you immediately get sine of u times 2u du. So you get 2u sine of u du, which is something that can be done in a lot of ways, integration by parts being one of them.
I think that's the substitution Ross Fu has made. I can't quite make out it. He didn't completely erase his old work. Is it u equal root x, or is there a 2 in front of that?
It looks like, yeah, u equals root x, written somewhat sloppily, which leads to dx equals 2u du. Yeah, exactly what I mentioned here. So now, yeah, he has 2u sine of u du. He has to integrate that. That's done by parts is a good idea for it. And, yeah, it looks like that's what he's going to do here.
1 minute expired, 3 left.
Looks like he made a mistake in the process of doing integration by parts.
Ooh, he completed the circle. Li Yu on the left, circled an answer.
He has this, both guys have 2u sine of u
Oh, that's really sucky.
du. And it looks like
He got it wrong.
he got it wrong, and I'm sure that was a silly mistake. He had it in 2u sine of u du as an integral. And now he runs up and erases his answer.
Defense. Hadn't thought about that before. 2.5 minutes left. Rossfu back to his own board.
Rossfu's really just got to execute his basic skills at this point. 2u sine of u du is an integral that even 1801 students have probably run into at least once. So hopefully these guys won't freeze up, and well, at this point only Ross can make something happen. In my opinion, the best ways to do u sine of u du in some form would be, well, you can do integration by parts and get rid of the u in one of the two terms, thus making it a nice integral, or you can do some sort of undetermined coefficients, which is pretty similar to what integration by parts actually is. Undetermined coefficients, just sticking some sort of au sine of u plus b cosine of u plus c sine of u, something like that, and just trying to figure out which of those coefficients work out to make it work. Whether or not Ross is going to be able to execute here.
So
yeah.
A minute and a half left.
Yeah, he's got the whole integration by parts going on here. He's got negative 2u cosine of u. That's the first term. That is correct. The second term is minus the integral of 2 sine of u du. That's also correct. He's just got to evaluate this.
So make the right substitution. Looks like he's gotten the first term.
Ugh, cosine pi squared over 4. Well, he's got it. He's only got a minute left, though. I'm sure the pressure's building. Even I have butterflies in my stomach right now trying to figure out what exactly is going on here.
You wonder if the judges will be lenient with the most normal form. You also wonder if these guys are going to run into the buzzsaw, the number 1 seed in a minute. Uh-oh, some side work.
It's not looking good.
That's
He's only got
never a
30
good
seconds
sign.
left.
26 seconds now.
I really thought the
He's
pi
stalled
squared
out.
over 4. What he's forgotten to do is he's forgotten to stick. Oh, this is really unfortunate.
forget
He's
the
forgotten to
substitution?
substitute the u and the x's back in. That's what makes it nice, and that's what I'm sure he's wondering right now, because pi squared over 4 is the square of pi over 2, which of course would make this a very nice and easy integral, and this is really, really unfortunate. Really unfortunate.
He circled an answer, but that's not going to
He
cut
can't
the
have it.
mustard
He
here.
forgot to substitute back in. And I'm sure he was as stunned as I was at first looking at that cosine of pi squared over 4.
Yeah.
And the answer is, yeah, just 2. I mean, when it comes down to something that basically went from 0 to pi over 2 in some form, that's what the answer is going to be. He forgot to substitute back in, and that's a real shame.
Well, let's see how the tournament director handles this one. We're 0 for 5 now,
Continuing on with best of 1.
and we're going to keep plugging away.
Well, new life for Li Yu. Hopefully one of these two guys can get this integral so that we can simply move on, because I'd really like to see some of the other contestants and how they fare.
As would I.
We've gotten some animated discussion and some interesting stuff going on with these two guys, but at a certain point you just want to see someone solve an integral so we can see some of the other people and what they can do too.
I'm eager to see some of the extreme integrals, and it doesn't seem like we're anywhere near that point. So here we go, 4 minutes again for this problem. Should have kept the clock at 3, at least we would have saved some time.
At this point, in retrospect, that would have been the best move.
Okay, another definite integral from 0 to pi over 2 of sine x cubed.
This is really a subset of one of the earlier integrals that also could have involved sine x cubed if a substitution was made in a certain way. So I imagine somebody's got to get this one.
If they learn from their mistakes.
That really is the question now. With 4 minutes to solve sine of x cubed, there's a lot of ways to approach this. I think breaking it up into sine squared and sine may have some promise, since then you can get something like 1 minus cosine squared
And that's
sine.
what Ross Fu's done. He's got sine x, 1 minus cosine squared x.
Since then, sine of x is the derivative of cosine of x, so you can do some sort of substitution at that point, such as, I would say u equals cosine x, du would equal negative sine x dx.
Li Yu has circled 0 as his answer.
Yeah.
Okay, clock started.
Well, I lost that one.
And he's wrong.
And he is wrong. Li Yu is furious with himself. But yeah, I mean, that's just...
Hard to see how that would be 0.
Yeah, that doesn't make any sense.
Sine x doesn't do anything but go positive.
Sine X stays positive on that interval, so it really makes no sense at all.
We have an answer. Oh, Ross Fu circled 4/3. I didn't even notice.
And the answer is 2/3.
He must have lost a factor. I see a 1 minus a third on the left. Is that? Oh, there's some other terms. I'm not sure what happened.
I can't really see his board too well right now, but I'm really wondering how both guys managed to botch this. Lee Yu's was especially silly, although when you're up there, that's really not the way you're thinking. I think when you've got a calm and steady position.
Lee Yu getting a drink of water here. I think Ross was proposing, I'm sorry, when I refer to Ross, there are two Rosses in play. Ross Fu is the gentleman on the right. Ross Lippert, sitting at the computer, is running the integration bee itself. So Ross Lippert is contemplating, I think,
giving it
a disqualification, perhaps.
He might just want to give it to.
Oh, he's going to give it to him.
Not sure. It looks like he's. At least they only took up about a minute and a half on that one. Clock has now hit 6:50 in this first round.
Okay, here we go. I think this is round 6. I have to admit I've lost track. Back to the indefinite integrals. 2x over 1 minus x to the 4th square root.
This is an interesting one. I think that, well, I've said this a couple times now that I think that one of the guys has got to be able to get this.
Ross didn't even start the clock for a while. He circled an answer.
Yeah, and I think he's right.
Lee Yu circled an answer, no work on the board, inverse sine of x squared, and I suspect by his reaction that that's wrong.
Yeah, he fell into the same trap.
Thank you.
Or,
Are we both eliminated? Is that correct?
okay, that's what I thought. I was trying to figure that out. You've got an x to the 4th on the bottom, and you've got that 2x on top. So if you think about the chain rule, having an x squared inside the sine inverse will pop out a 2x and still stick out the nice 1 over square root 1 minus x squared, except it's 1 over square root 1 minus x to the 4th this time, because you've got x squared inside the sine inverse. That was impressive. We have a 13-second answer after, what, 5 or 6? I've lost track of how many rounds have gone by.
I was going to ask if we can expect someone to just bust out with the answer, no work, nothing, but there it is. So
oh, well, maybe you should have voiced your concern and made yourself look a little smarter. And here, we've got a big ovation for these first two guys. It really could not have been easy for them. It really could not have been easy to be the first guys up there and just not getting any integral. And they're going to make this next round best of 1.
So we're still in best of round. This is now, this should be David Shin on the left.
And Senya.
Pensia Samokvalova on the right. I fear I didn't get that name correct.
We've got some introductions, some contestant introductions from James Albrecht, one of the organizers and the primary question writer for this year's integration bee.
So here we go. The integral's up on the board. It's a definite integral.
Well, I believe this is just, well, you've got arc sine on top, and then you've got the derivative of arc sine on the bottom. So I imagine,
well, if
and I
nothing
can't
else,
see
David Shin writes very quickly. Sort of chicken scratch writing like mine.
And yeah, I mean, I see the, I believe that's arc sine of x equals u by Xenia here, which is what I would at least think of first, simply because you've got its derivative. Whenever you have a function and its derivative in the same integral, odds are you want to do some sort of substitution involving that, and it should simplify the function dramatically. But neither contestant has circled an answer as of yet.
The time pressure is tough, though. These guys have waited for an hour. They
Yeah.
go up to the board, and it could be over in a minute if the other contestant gets it. So you're just working so quickly, but that means substitutions you see easily sitting on a desk.
Probably
a little bit harder. We have a picture. I think we have
David
a
Shin with a
graphical
graph.
There we go.
That might be exactly what it needs to be. It's possible when we're talking about arc sines here, you got some sort of triangle things going on.
This is a man who works with purpose, though. That's for sure. Looks like he substituted in some numbers.
I mean, I believe the derivative of arcsine is 1 over square root 1 minus x squared. I almost hesitate to admit that I am a math major.
He circled an answer and immediately starts to erase the rest of the board. 1/2 minus pi root 3 over 12, is it? But it's not correct. So just over 2 minutes.
That could be
Kensa
unfortunate
gets
for David
a second
Shin.
shot at it. He's quickly erased the board. Boy, people learn quickly, though. There won't be any looking at the other guy's board for the rest of the day.
Tough break for David Shin, who I personally know is an extremely skilled problem solver in an Olympiad and contest problem sense. I believe he went to the International Math Olympiad in high school, and that was a good 4 or 5 years ago, which might have contributed to his blitzkrieg at the beginning there.
Yeah.
But unfortunately for him, it's first to 1 now, and through no fault of his own, really, he may end up losing any opportunity to bring himself back into this one. I mean, I don't even remember what the derivative of arcsine is. I'm going to be perfectly honest. I thought it was 1 over square root 1 minus x squared. I'm pretty sure that's what it is. And yet...
Stop.
Wait a minute.
David Shin's answer
I
was...
think the judging panel concluded that David was correct.
No, it's...
Well, pi over 4 certainly isn't what he wrote, but what are we doing here?
I think he left it in some unsimplified form that was equivalent to the actual answer, and the judges, the organizers told me before the contest they weren't going to punish people for simply not simplifying constants totally, just because that's really not what this contest is all about.
Sure.
And now I'm getting blamed for that answer being wrong. But I know I didn't write that integral, so I really don't know how I can be blamed for that. I think James is just trying to poke some fun at me. We are roommates, so I'm sure I'll be able to let him hear about that tonight.
So in just 2 minutes, David Shin does the work that took 20 some odd minutes for our first round. And we're now down to the desired 8.
Now should we do this best of 2 or continue on with the brutal
Now there's a discussion about whether there should be face-offs.
First two.
You guys gotta be good though.
Okay.
So we have.
So they're resuming the first of 2 format, but James is warning the contestants, you guys better be good. And I think at this point we all hope that they at least do fairly well on these. I'm sure as much as the audience is interested by these integrals, we don't want to stay here a good 3-4 hours. Hopefully that won't be necessary.
So just to review
So
where
we
we
have,
are, it's 7 o'clock.
Bobby Lou
We've eliminated
and,
2 of the 10 competitors. We're now down to a grid of 8, standard seating elimination setup.
Is a junior
And
double majoring
we welcome the next round of contestants up to the board.
Then we also have
We've got Bobby Liu and Taiji
He lives in
Hao.
Simmons. He's a sophomore and is majoring in physics.
They're giving David Shin and Lee Yu an opportunity to rest here as the 3rd and 6th seeds, and then it would have to be 4th and 5th seeds are going to face off next.
Integrals up, there's a floor function in this.
Oh, this is a very interesting problem. I remember seeing this in the process of organizing the competition. It looks very intimidating. It actually comes out to be very easy because while a floor function is intimidating, if you think about it in terms of integration, all that means is it's flattening out the curve to make it a lot easier for you to evaluate what's going on. I think once one of these 2 guys realizes that, they will get the right answer, because there's nothing else you can do with a floor function. So at a certain point, they've got to be like, well, I need to just see what this floor actually does to the function. And I certainly hope one of these 2 guys will get it. I believe one of them will. The pi there is just to look scary, I think. I'm pretty sure it really doesn't make too much of a difference what it actually is. It only matters that pi is between 3 and 4 in this case. Because, yeah, what you get is, well, you basically get 1 over pi. 1 over pi in this case is, well, the floor of that is 3. And 1 over 2, the floor of that is 2. So it's really just you're staying on
How much 3 and how much 2?
Yeah, exactly. How much of it is log 3 and how much of it is log 2? And I believe the entire part of it is really log 3 because 1/2 is the first number. Oh, no. I'm sorry. From 1 over pi to 1 over 3, it's going to be 3. And from 1 over 3 to 1 over 2, it's going to be 2. So we should get, 1/2 minus 1/3, which is 1/6. We should get 1/6 times the log of 2 plus 1 over 3 minus 1 over pi times the log of 3.
Just a reminder of viewers, log is natural log in these problems.
Yes, which is actually the way it generally is in mathematics in general. I believe ln, the natural log convention that all of us are so used to seeing from the United States, is more or less unique to the United States, actually, from what I've heard.
So
I
I'm a
might be
computer
wrong.
scientist. Log for us is base 2. Course dependent, as they say.
Or if you want to go over to chemistry and look at pH, you've got base 10 for that.
So we have an answer circled. Probably.
He has negative 1/2 ln. Well, that's. I can't really tell what he's got written there. It's a little messy.
It's a beefy answer.
I'm not sure if what I said earlier was the correct answer. It seems right to me, though.
So the judges have said no.
I mean, I believe that the function from 1 over pi to 1 over 3, you've got log of 3 the entire time. And from 1 over 3 to 1 over 2, you've got log of 2. So I imagine whatever that corresponds to is the answer. But I might just be messing things up here. I don't have pencil and paper in front of me. And that would certainly be somewhat handy, although I don't envy the position that these contestants are in right now, I've got to admit.
It is a pressure cooker. You got about 100 MIT kids now. The room's dark. I mean, this, just to set the stage for you, you're in a dark room. The only lights are focused on you. You're at a blackboard. It's an integral that doesn't look pleasant, at least to start with. And 100 of your peers and 6 of your competitors are staring at your back.
You've got an answer circled here.
Fair bit of thinking. Then he circles. Not much written on the board.
I can't really tell what
Looks
he's
like
got
he wrote
written
the
there.
problem and he wrote the solution.
Negative, everything in parentheses, 1/6 natural log of 2 plus natural log of 3 times in parentheses 1/3 minus 1 over pi.
I think he's got the 1/3 minus 1 over pi on the wrong side of that. Or no, it is correct. He's got it, okay, yeah.
Same way, but he's got it. Oh, well.
1 over 2 minus 1 over pi log 3. Is that what it's simplified to? I'm going to have to go back and take a look at that one myself to see where I went wrong on that.
So this round again, first to 2. Now 1-0.
And yeah, Taiji did get credit for that, I believe.
Looks like there'll be a quick discussion among the judges.
Having written a good chunk of these integrals, I believe James has a fairly good handle on what the answers are. So it's going to be his opinion that matters most, I believe, from the judges.
So we think Taiji has credit. The next integral's up on the screen. He could win and move to the semifinals if he gets this correct.
And this isn't really that hard, actually. You've got 2x secant x, then you've got x squared secant x tangent x. Well, it might be harder than I thought it was at first, but the derivative, if you think about these functions are all very related in terms of their derivatives.
Bobby Liu in a hurry.
Exactly, he's got it. Exactly, x squared secant of x, because if you know the derivative of secant, it's just really a matter of product rule. 2x secant x and x squared tan secant.
So Bobby Liu quickly answers in just 24 seconds.
This is one of those tricky integrals where it just looks very hard, but you've got to notice some things about the parts of the integral itself. It's not always just about plugging away at it like evaluating polynomial integrals might have been in calculus, even though you certainly could have gotten this integral just from your calculus skills. And Bobby Liu showed off his problem-solving intuition on that problem right there. I think maybe the most striking part of that integral was the fact that it was a sum. You usually don't see sums that are just straight out separate like that in an integral unless there's something goofy about the sum relating to product rule. Because otherwise, sums don't really complicate the difficulty in integral, it really just makes it into 2 integrals. But in that case, splitting it up would have been a disaster.
Sure. So here's the rubber match. One apiece thus far. Taiji on the left, Bobby on the right. The first to get the next integral correct moves on to the semifinals. This is the first of 4 quarterfinal matches.
Well, we've got x plus x to the 4th on the bottom. I wonder if they just want you to split the top into 2x cubed and minus 1, and split the bottom into x times 1 plus x cubed, since 1 plus x cubed is factorable. But whether or not that will lead to good things. If you factor 1 plus x cubed, I believe you get 1 plus x times 1 minus x plus x squared. You'll also have another x stuck on that in some fashion, which makes partial fractions seem like a pain to me.
That's Bobby's approach, and he's stalled out.
Yeah, he probably had the same initial instinct of being able to split up the problem in some nice way. I think that the fact that there's an x cubed on top and the potential to get an x cubed on the bottom is what he's got to really think about here. Because having that x squared minus x plus 1 as one of the items in the denominator doesn't look too good. I also want to mention that it is somewhat surprising how tough some of these integrals are when you consider that it's really just some polynomial over some other polynomial. These are all things we're all used to. We're not seeing the craziest things out there. We're not seeing huge numbers. We've got a 2 and a 1, a 3 and a 4 up there, you know, in various forms. And yet, this is a tough integral, taking a lot of time and thought from these competitors, and I'd imagine many of the audience members and viewers as well.
How'd you get involved in this?
To be perfectly honest, James and I, as roommates, simply just decided we wanted to participate in this in some fashion. And I'm not sure if we really wanted the pressure of competing in it, so we decided, hey, why not run it?
The end run.
Exactly. I'm not sure if...
Okay, Bobby Liu has circled an answer, a couple of logs. Log x plus 3/4. Hard
Simplicity.
to read, 2/3.
Simplicity is generally a good thing. His thing doesn't look too complicated.
No dice.
But no dice there.
Minute 30 left. Next man to get an integral moves on. I'd say the loser goes home, but this is MIT, and it's not clear that home is more than 100 yards away.
Bobby's kicking himself right now. I'm pretty sure he's figured out what he did wrong.
It's funny how often that happens.
It is funny.
If you could get one, am I on the right track or not?
Yeah, and you have to also take into consideration that mathematicians certainly aren't used to a stage like this. This goes against a lot of the basic grains of mathematics, being able to sit down, calmness, not the pressure of having some sort of timer winding down. That's not math, that's sports, isn't it?
It's Apollo 13 maybe at best.
Maybe, exactly. And yet these guys are here, and maybe the first pair of contestants didn't react quite as well as they would have hoped, but overall it seems like these guys have done a fairly decent job. David Shin was able to get his problem quite quickly, and now both of the first 2 integrals for Bobby Liu and Taiji Hao here have been solved immediately. Or not immediately, but at least solved.
Not this one, though. 20 seconds left, and it doesn't look like Taiji is going to come up with an answer. His writing gets smaller as he moves down the board, so it's hard for us to see exactly where he is, but 10 seconds left. And I think we're going to move on to a 4th integral today.
4th round wouldn't kill us. Another 6 or 7 rounder might.
Yeah. And time has expired. No answer on the left for Taiji.
Let's see what the screen produces. And yeah, a surprisingly simple final form. Log of something, basically, is what it came down to. It's very interesting because if you take the derivative of that, you're going to have to chain rule it, and you wouldn't imagine that it comes out to something quite like what it did, but that's actually all it was the derivative of x squared plus 1 over x was that chunk that we saw, aside from the 1 over x part of the denominator, which corresponded to the log.
So the 4th integral's up on the board now from 0 to infinity.
We've got 1 over, and in the bottom we've got the quantity x plus the square root of the quantity 1 plus x squared, all of that squared. Be interesting to see what role that square plays. I'd imagine there's some sort of very snappy trick here, simply because when a problem is this ugly, it's got to be pretty at some point. Otherwise, I don't think it would be on this contest.
Right, remember, we're not asking them to integrate arbitrary expressions. There's a structure or a trick or a pattern or
Exactly.
some kind of internal beauty to each of these. And in some sense, the worse it looks at first, the
better it actually
nicer
turns
it
out to be.
collapses.
Oftentimes you'll see problems where, like we saw earlier, there's just a product rule, or perhaps some sort of immediate chain rule produces the expression next to the integrand, and then it's just up to you to notice, oh, there it is. Snap your fingers and circle your answer without any work.
So I see x equal tan u on both boards as a start.
Probably a good idea, considering you've got a 1 plus x squared of some sort. I wonder what pain you would be in if you just tried to expand the square in the bottom. Seems to be a lull of sorts here. Both guys look to have made some progress. Bobby Lou's got quite a bit of stuff on his side.
You can kind of tell, though, when they've been solved, it's been quick and it's had a certain flow to it. We haven't seen anyone kind of muddle through a problem
and then get it at the end.
And then get it at the end. So
definitely. And I think that is really a fair representation of the way these integrals have been. When they've been solved quickly, because they certainly can be solved quickly. When they haven't been solved, the tricks just haven't clicked for the contestants up there. And when the tricks don't click, it's very hard to do much else.
So just over a minute left. This is the fourth integral between these two. The first two were solved very quickly. Bobby Liu in particular nailed the second integral in just seconds. Saw the immediate substitution and did it. But the previous one and now this one have stymied both the competitors. And it looks as if we're going to move to a fifth.
When you've got glances at the clock, you know that the competitors aren't completely locked into what they're doing, which means they don't have the utmost confidence in what they're doing, which means odds are what they're doing is not going to lead them to the correct answer.
So you did say that this would be less of a speed competition and more of a skills competition, but maybe the dial got twisted a little bit too far to the right?
Might have been. The viewers should understand that the writers of the integrals and the judges in general, myself included, James, we have also Billy, Eric, and Sid. None of us are exactly superstar mathematicians by any means, so it's not like these integrals are just absolute death or anything. But at the same time, there is a big difference between working something out, sitting down, and just working something out in this stage, and I think we're really noticing the difference at this point. The answer to that was just 2/3.
Oh boy.
I think people get in the first 3 minutes, so they don't.
Yeah, and I hear someone in the crowd making that same observation. Either you get it immediately or it's just nothing, and you're sitting there spinning gears.
Yeah.
Let's wait till you're up.
Sounds like the clock might go back to 3 now.
We'll make the semifinals.
We'll see.
Turn the semifinals back.
Going back to 3 might not be the worst idea, considering what we've just noticed and heard.
But we'll be at 4 for this one. The integral's up on the board. Log of x all squared, or log squared x as I used to write.
This will be interesting.
Both contestants with quick substitutions. Tough to see what Taiji's writing. He has that small writing style, but he's moving quickly. Bobby Liu also moving fairly quickly. And Taiji has circled an answer, 3 minutes, 31 seconds on the clock. Waits for the judges. He's got it. He's got it. So the small integrals expand a little bit. The big ones collapse. But Taiji has moved on to the semifinals. Bobby Liu will take a seat.
And I think that this won't be the first upset, quote unquote, necessarily tonight. Taiji was the 6th seed. Bobby was the 3rd seed. But like I said earlier, I really don't think there's too big of a difference between all the contestants here
Now we
tonight.
have Matt Tybalt versus Yogesh.
Another 4 versus 5 match. Matt Tybalt on the left, Yogesh Ramadas on the right.
He lives in McGregor. He's math major with econ minor. And he's a senior this last year. And Yogesh, he's a grad student in the 2nd year.
Undergraduate versus graduate.
I know for a fact
how
that
that
Matthew
plays out.
Tybalt is an excellent problem solver simply from his performance on the Putnam exam, which some of our viewers may be familiar with. He did quite well last year, I believe placing somewhere around the top 30 in the country.
So the integral's up, 0 to infinity again. Are all of these 10 contestants MIT students? In one
Yes,
form or another?
they are all MIT students, although technically the event was open to pretty much anyone affiliated with MIT. You could have had anybody show up, including professors, but professors have just never chosen to show up. We've got an interesting e to the negative x squared as part of the integral here, and we've also got times 2x squared plus 1, which leads me to believe that it really can't be too bad simply because e to the x squared is very bad to integrate. It can't be integrated in an indefinite form, at least not in some sort of closed expression involving the standard numbers that we're used to seeing.
Yogesh pauses to think, goes back to work.
Matthew Tybalt standing there really trying to process what exactly he should attempt, maybe first or maybe second here.
Could make a movie out of all the different head scratching.
Yeah, we most
going on
definitely
here.
could.
Everybody's got their style of thinking. Jacking up the font size here. I don't know if I'd mess with the integral during the round, but
Tybalt does a little dance. Probably a little frustration there.
so here's another one. We're approaching the 2-minute mark. Neither contestant seems to be on track with
I don't
a solution they're
necessarily
comfortable with.
want to venture a guess at what the derivative of e to the negative x squared is here without actually writing something down. But I'd imagine it has to have something to do with this problem. Simply because, well, you've got 2x squared plus 1 times e to the negative x squared. And, well, any derivative of e to anything will still involve that e to anything in it. So it seems to me like the constant, well, not constant exactly, but what's in front of the e has to have something to do with some nice clever trick in doing this problem.
Minute 30 remains. I have to say the crowd has held strong through this first hour and 15 minutes. I guess about an hour of integrating.
Another thing that surprises me is it doesn't look like.
Okay, we have
from
another
what I can
graph, I'm
see.
sorry, on the right. Yogesh has drawn some sort of,
Graphs
and
seem
he
like.
circled an answer.
Oh.
I think he took a different approach to thinking about the problem. He circled root pi over 2.
Yeah, I didn't think.
Not so much.
I didn't think that it would just work out like that. The value of the integral of e to the x squared from at least with one of the limits equal to infinity is known, and is, I guess I would venture to say, commonly known among experienced mathematicians. So maybe Yogesh thought that that knowledge was actually all we were thinking about here, but that isn't the case. All of these should be integrable without any sort of extra knowledge like that, and in this case it didn't quite work out for Yogesh.
Oh, not good when you end with question, question, question. 8 seconds left. I don't think. Oh, he circled.
Highball may have just done that out of desperation.
2/5 maybe? I can't tell what he wrote.
And he gets a wrong thrown at him immediately.
Root pie.
Answer just root pie. Woo. Yogesh misses by a factor of root 2, which is tough.
Okay, no progress in the first round. We'll give him another problem and see what happens. This is still a quarterfinal match, the second of 4.
Ooh, we got some nasty business up on the board here, but this is the kind of problem where an experienced problem solver might notice the trick immediately and know what to do, because when you've got stuff like cosine 7x, cosine 17x, cosine 37x, I mean, come on, it's got to be easy. Otherwise, how could it possibly be on a 4-minute format contest here? And by easy, I mean it's got to be quick and easy if you see the trick, which is by no means easy itself. If some of our viewers remember back from high school math contest days or things like that, I'm sure they've seen at least some of those goofy trigonometric expressions from competitions such as the Amy, Armel, and other contests. So we'll see how much of that. And yeah, we got a 0 here from Yogesh. He gets the right answer. I didn't want to float that out. I didn't remember the answer to this was 0 simply because we had some nice and fun discussion about it while preparing the problems for this contest. There was a semi-bet going on of sorts of whether anyone would get this, and really the consensus ended up being that not only would someone get this, but odds are they'd get it pretty fast. And it looks like we were right, at least for once.
Yogesh Ramadas with the first point here in this quarterfinal round. Here's another one. Wow.
And we've got sign of
as if these guys are just in a different contest.
The problems were randomized before the contest, and I'm not sure how exactly that randomization was done, but it looks like some similar veined problems did manage to stick together through all that process.
So this one's an indefinite integral, but same sort of shenanigans going on.
Well, you've got sine of 101x, and then you've got sine of x to the 99, which really, there's got to be either, well, some sort of substitution. Something's got to connect the 101 and the 99, perhaps complex exponentials of some sort. If our viewers are not familiar or may not remember quite clearly, a lot of integral problems that deal with trigonometric functions can be approached with complex exponentials. That is, something e to the negative ix minus e to the ix minus e to the negative ix, or something of that form. And I'm not sure if our contestants here are going to go down that path. Not too much on Yogesh's board there. Another thing that I might consider at this point, if I have no other leads, is maybe to try this same problem except with smaller exponents of some sort, maybe 3 and 5 or something, since I highly doubt that the 101 and the 99 themselves are critical to the problem.
Sure.
And that's another thing, that tricks like that are things that you keep in mind through years of experience and really just through years of failing to solve problems and then seeing the solution and smacking yourself on the head.
It's just how often does that take place in front of a room?
True.
So we passed the 2-minute mark.
Both guys have stalled a little bit.
This one's tripped them up. Integral of sine of 101x times the sine of x to the 99th. Yogesh on the right, seeded 5 for what that's worth, but does have the 1-0 lead. The first to get 2 integrals will move on to the to the semifinals and join Taiji Hao, who won our previous round. Took him 5 rounds to advance. Yogesh could do it in 3, but with 1:15 left, we'll probably have to see a
fourth or maybe
integral.
5th at least.
It does seem like this is the kind of problem, though, if you just stopped and stepped back and thought for a minute, you could get the answer very quickly if it comes to you.
Something certainly potential to have something click for a problem like this. But that's yet another way the time factor really comes in and plays a role, because it's really against everyone's natural instincts to just step back and not write stuff down as soon as they see a problem in a time contest where speed is, at least in theory, what counts.
Sure. 30 seconds left. Quickly remind everyone, Sportcast here at MIT is brought to you by the Student Information Processing Board, the MIT IS&T Department Information Systems and Technologies, along with generous assistance from the MIT Athletic Department, and this evening for our special presentation, the MIT Department of Mathematics. And it looks like this one will close out with no progress on either side, so the clock expires, and we'll move on to a fourth integral.
I think both contestants are a little curious as to what it's going to be.
Ooh.
Judges, how the hell do you get that one?
Oh, it's kind of cool.
It's kind of cool.
Sine of 101x is sine of 100x times cosine of x plus cosine of 100x times sine of x. And then it's just, then you have u dv plus v du. Oh. And then it's just,
We get a lot of groans from the crowd here. And seeing the answer, it leads me to believe that my little idea would have worked out, at least in some capacity, since it was really only the difference of the numbers present on the board that mattered. So 2 and 4 or 1 and 3 probably would have led to an answer that could have helped one of the contestants guess what the answer should have been. Now we've got a tangent and a secant, which are always good to see, except the secant's under a square root, which is not quite as pleasant. We'll see what the contestants are able to concoct here.
We have an answer on
Answer
the left.
from Tybalt.
1 over root of, he's got it.
He's got it. That was very impressive. He saw exactly what to do as soon, immediately.
So he's tied us up. We're at 1 apiece now. 1 apiece. Matthew Tybalt now with 1. Yogesh Ramadas on the right with 1. Next one to get an integral will move on.
And it's instances like that that help all of us watching here to appreciate how good some of these guys really are. They're not going to get all the integrals, but sometimes the speed and accuracy with which they perform is really something to behold.
It's 27 seconds for that particular exercise. So round 5.
There we go. We've got a cotangent minus tangent on the bottom, a cosine 4x on top. I don't remember seeing this integral in preparation, so I really wonder where it came from, but it'll be very interesting to see how it plays out. Cotangent minus tangent might look ugly, but if you think about it, you've got cosine over sine minus sine over cosine. So when you try to put that together, you get some semi-reasonable stuff, such as cosine squared minus sine squared, which is cosine of 2x, and on the bottom, cosine of x times sine of x, which is 1/2 sine of 2x. And once those 2x's pop up inside the sines and the cosines, the 4x looks at least a little bit more reasonable.
Sure.
An answer by Tybalt, is that correct?
Negative cosine 2x, I think, is what he wrote.
It can't be just negative cosine 2x, I believe. Or can it?
Oh, he felt it, though. It's not simplified completely. Okay. That's
Confirmation,
wrong.
that is wrong.
Clock
Tybalt
restarts. That might be an expensive mistake in this round.
That might be. Both of these guys have shown some serious displays of skill. But yeah, it's not going to come out to something quite as simple as what Tybalt got, unless the thing inside the integral itself actually simplifies dramatically. But I don't think it's simplified all the way to where
Now
Tybalt
look at
had
this.
it.
He's still working.
Well, that is a sign of a true mathematician right there. Tybalt definitely cared just as much about why he got that problem wrong specifically as about just doing well in this competition.
So we've gone from defense to just solving it on your own time, and now he's pacing, a little frustrated. He felt he had it, and I think he was extra excited because he was down 1-0 and had come back.
And with the speed at which he got those 2 problems, it certainly would have been very impressive if he'd solved another problem, certainly not obvious on sight, in such a short period of time.
So Yogesh still has 2 minutes to work. You don't get the sense that he's sure what to do.
The +1 is very curious to me because, well, you cosine of 4x, if you use the cosine 2x identity, you end up getting, I believe, 2 cosine squared 2x minus 1. So that'll wipe out the +1 and possibly explain why it's there. In which case you would end up with 2 cosine squared 2x over, on the bottom you had, I believe I mentioned earlier, it was cosine of 2x over 1/2 sine of 2x. So then it looks like you just get 4 tan of x, or I might have messed up where the 2's go in that. But yeah, I think that comes out to, oh no, that comes out to 4 sine of x cosine of x, which is, oh, Tybalt was very close, I think. 4 sine of x cosine of x. 4 sine of x cosine of x is simply, and yeah, there you see it, -1/8 cosine 4x. Tybalt had the right idea because, well, what you end up with is something very close to the sine 2x identity, and as you can see, the answer did turn out to be relatively simple.
And we are coming
So
in
that
at the end.
early guess does prove costly. Yogesh moves on as the second of 4
Chairman David,
semifinalists.
you guys remember David Shin from
David Shin back in action.
And then we have Sharon. He's 5th year PhD. He always students max this year. He lives in SIDPAC and he's a mechanical engineer. So without further
You've got a grad student, I believe, 5th year.
Let's go, David!
Taking off against David Shin here.
He's got the crowd behind him. On
David
the
Shin's
right,
got some serious fans here. Shirtless fans, I bet. I wouldn't be too surprised if David Shin managed to pull off what would be an upset here. But then again, I still haven't seen Shuram perform yet, so I can't say that with too much certainty.
Shuram is seeded number 1.
David, should I set the clock for 3 minutes?
I believe
the
his,
results from the preliminary round last Thursday.
I do believe his performance was quite impressive. The top 4 were all pretty close, and overall everybody was fairly close. And now the same problem just appeared twice in a row.
False start on the moderator. Crowd's still coming into the room. The crowd is growing in size.
I haven't really seen many people leave, if any at all.
You know the excitement's just around the corner. These
This
semifinal
one.
rounds, when we bring out the extreme integrals.
X cubed e to the x squared, that really has no choice but to be simple somehow.
And Shuram quickly off to work. Both contestants off to work. Let's see. That is a man integrating with purpose on the right. And he's circled an answer, squared an answer, but we'll give him credit for circling.
He didn't mark it, did he?
And I guess that's wrong.
I guess. I don't know if
That's
there was
wrong.
an issue
Boy,
with
that
him
was-
marking something there.
I saw him touch the board after he squared. I thought he was just erasing some extra chalk that clouded the answer, but
I'd imagine David Shin has a very good chance to score the first point here.
still over 3 minutes. This is the first question these folks have faced.
Something else to note is a drastic reduction in the speed of work by David Shin now that he knows he has time. Certainly the speed element of this contest has affected the approach of all the contestants, as just evidenced there, because both of those guys came out just blitzing, and now David Shin is really just taking his sweet time and trying to make sure that he doesn't give up an opportunity at what could be a relatively free point. To me, what's most interesting about a problem like this is, well, you've got your infamous e to the x squared, which just cannot be integrated in an indefinite form. And yet, here we have an indefinite integral involving e to the x squared, and all that's happened is an x cubed has been tacked down in front, and all of a sudden things worked out. And that's one of the more interesting things, in my opinion, about mathematics, is you've got these things that they don't work out at all, and then suddenly you stick something in front, not just sticking a constant, you're sticking out a cube of something, and all of a sudden it's going to work out.
David Shin kind of stalled out here. A little less than 2 minutes. Shuram seemed more business-like than the other competitors. He did his work quickly, circled, wasn't right, erased everything, and now he's just standing patiently.
Shuram knows that he still has a chance, and David Shin circles an answer.
Circled the answer. It's been up there.
David Shin. Shuram was very close if you look at that. Shuram was very close.
He had that up there for almost a minute, just took his time, made sure it was what he was
I believe he just
with.
went out and decided to take the derivative of it, which is certainly the smart thing to do when you've got as much time as you want, or at least more time than probably what you needed there.
So the number 1 seed finds himself in a bit of a hole. Next one for David Shin, and he moves on. This is a definite integral.
3 to the square root of 2x plus 1. Interesting. David Shin once again coming out on fire here. Just getting a lot of stuff on the board. If that was the contest, David Shin would be the winner. Getting as much stuff on the board as soon as possible. This is a very interesting problem here. So you've got a constant, not just a constant, but it's not even really a goofy number. It's just 3 right there, sitting there with to the square root 2x plus 1. And I guess this just shows, you know, with a little creativity, you can get some very interesting stuff. And not certainly non-trivial integrals with really just nothing too fancy. You've got it from 0 to 4 there, and it's got a 3 and a 2 and a 1 and a square root. Nothing too ugly, at least at first sight.
Shuram's opted for T rather than U for his substitution.
Again, personal preferences, always interesting to note. I wonder how the 0 to 4 will come into play here. My suspicion would be that the 0 will go away in some capacity or force a 1 in an exponent somehow, and that the 4 is there because it's a square. But that's just my guess. I would be somewhat surprised if neither guy got this, since it seems like both came out of the gate, excuse me, with a sense of purpose.
They did, and I had a feeling David Shin wanted to circle what he wrote up there in the corner, but...
Well, he's leading 1-0, and right now just giving your opponent an opportunity of, say, 3 free minutes might not be the greatest idea.
He circled an answer, though.
He does have an answer now.
He's going to go for the kill. Judges are checking. It's not simple.
It's not simple, but they're not going to kill him just for that.
I didn't mean simplified. I just
Yeah.
mean it takes a second to verify.
Oh, that's true.
It's not the right answer,
It's
though.
not
so
correct.
Well, okay, they're not going to give it to him. He's erasing all that work.
And again, another incorrect answer. We've had a lot of those today, which shows that...
So Shuram has a minute and a half. Let's see if he can pull anything out of it. It's hard to decipher what he's doing. He kind of goes back and forth all over the board.
Yeah, he has stuff all over the board.
I've lost
which makes
track of where he's working.
Makes it hard to follow his spiral of work. At least that's what I suspect it's got to be. Looks like he started top middle or so, kind of went down, kind of went to the right, kind of came back up a little, kind of went to the left now. Now he's back down at the bottom.
One minute.
Both guys had the natural logs in there in some capacity, trying to figure out how exactly to manipulate this problem. And a natural log indeed is what you'd have to have, since the only pleasant integral of some exponential, some constant exponent is e to the x. Other ones are going to have to involve that ln somewhere. Shuram's got 30 seconds. Looks like he's almost starting over.
Yeah, it doesn't look like it's going to happen this one. Oh, well, nope. As soon as I say that, he circles an answer. Something over the log of 3.
Looks like 16.
Yeah,
No, he's not.
Was wrong. The real answer is 78 over the natural log of 3 minus 24 over the natural log of 3 squared.
So
look
the
at
answer on the board there is
78
wrong.
I don't know.
Do we have a correction? I caught the 24. What's the first term?
I believe it was 78 over log of 3 minus 24 over log of 3 squared, I think is what he said. David Shin maintaining his 1-0 lead. Sorry, go ahead.
No, that's exactly what I was going to say. Sharam will erase his board and we'll try a third integral. I love these guys, though. You're right. They come flying out of this when they start.
David Shin's got a little stretching going down there. And yeah, there is certainly a physical aspect to some extent. If you have ever tried to write very fast with a very focused purpose for an extended period of time. Oh, wow.
Oh, my.
That looks terrible, which means it can't be terrible. Or at least I would hope so. The x to the fourth plus 5x squared plus 4 are factors to x squared plus 4 times x squared plus 1. So, and both 1 and 4 are perfect squares. I don't know how that might help. You got an arctan on the bottom there with an x squared plus 2 over x. Like, this is really kind of nasty. I have no idea where I would start here.
So approaching 3 minutes.
Yeah, we're almost down to 3 minutes left here. And
This one's tripped him up.
the two speed riders here have seem to have run into a little opposition, fierce opposition with this problem.
We should mention, this is a medium problem. We haven't really gone over that. Most of what we've seen so far has been easy, but there have been a few mediums tossed in, and this is, I think this is the third or fourth one we've seen this medium. The pattern we have, at least in front of us, and I'm not sure this is being followed, but for this particular round, the third and sixth integrals are medium, and they're the first ones we've seen. So
yes. I wonder what that bodes for the semis, which are supposed to start with mediums and go to hards. And by hards, they're actually marked as X, extreme.
we haven't seen an extreme integral yet, but this gives you a sense of what it'll look like.
Again, the absolute complexity of the expression leads one to believe that it can't be too bad once you really figure out what's going on.
Sharam's had to shift down to a smaller font size to fit everything. I mean, there's just a lot to work with here.
David Shin's worked himself into a corner.
Less than 2 minutes. They do have another board. We haven't seen that in a while. They also have an eraser. Oh, he's going to use it selectively. And then the hand. He's going to... Oh.
The fact that these contestants haven't lost their head after seeing this is really very impressive in my eyes, because
No, they're both motoring along now.
certainly I wouldn't fault anybody for freezing after seeing this and simply just staring at it and maybe kicking at the wall a little bit.
One minute left.
Now we've hit a little bit of a lull.
Yeah, David Shin has the 1-0 advantage, but this one, the medium might be a bit much. Both have moved to a second board. Oh, now Sharam's going to go back to the first board.
It seems the board system has at least been fairly effective thus far. The audience seems quite captivated, and it does appear that almost everybody is in a position to see pretty much most of what's being written on the board. Yeah, we're about down to 15 seconds here, and I don't believe there will be anything produced on this problem.
Well, Schramm's going to try something in the last 7 seconds. He's
David
writing
Shin.
something down.
David Shin wandering a little bit, giving
Like,
up.
make my day, buddy. And nothing circled. So a defensive cheer for David Shin's fan section.
Wow, it was just log of arc tan x plus 2 over x. And that's not, now having seen the answer, of course, it's easy to be, oh, well, you could have done this or that, but I guess that was the most logical explanation for the existence of an arc tan x squared plus 2 over x, which is equivalent to what we have there, in the denominator of an ugly function. The only real explanation for that would be that something like this would be the answer. But of course, in 4 minutes, to expect to figure that out and see it, not the easiest deal.
It's a tall order. Okay, here's the fourth integral.
We've got a 3/4 power in the denominator to go with an x to the 4th plus 1 inside the parentheses corresponding to that 3/4 power. And to top it all off, there's an x squared just to make everyone, happy, I guess.
Both guys writing quickly again. And just as I say that,
Both low. David Shin's pulled out a substitution of sorts. The real question is what to do with that 3/4. It just doesn't seem like there's anything you can do at first sight that would really make it go away or make it into something a little more pleasant.
well, so Shrim has x to the x. Is it x cubed plus 1 equals t to the 4th? I can't tell quite what he did on the left.
It does look like x cubed plus 1 quantity is going to be t to the 4th here for sure.
David Shin is stalled.
Yeah, David Shin seems a little lost right now. Shuram is the only one really hammering away right now.
Now we're back to the easies in theory, but as we've seen, some of the easies have stymied everyone. So
This has been the ugliest easy, in my opinion, thus far. Simply because of that 3/4 power. I'm not sure what you would do with that.
looks like David Shin went to the graphics again. Just a way to kind of visualize what's happening. I remember when I learned physics, I finally understood some of the calculus that had eluded me at first. Just getting a mental model of how things fit together can help a lot, but I don't know if it's going to do the job here. Minute and a half.
Shuram goes to a second board here.
Yeah, he's excited about his line of thinking.
Now the question is whether we get an excited circle or a dejected slumping of the shoulders.
Right. He's got a minute left. It's plenty of time. I think David Shin's calling this one in. He doesn't.
Yeah, he doesn't look like he wants too much more to do with this problem. And having stared at it for 4 minutes here, I honestly can't say I'm sure of anything at all to try here. You've got to get rid of that 3/4 somehow. or maybe it's just supposed to be there, and then so you have x to the fourth plus 1 to the negative 3/4 power on top, effectively. And I can sense that the answer is going to be something somewhat simple, whose derivative comes out to this cleanly, some like x to the fourth plus 1 to the 1/4-ish kind of thing, because that was a 1/4 power would lead to a 3/4 power. Yeah.
Oh, there you are.
Negative a 1 plus x to the negative 4. Is that a negative 4?
Yep.
Yeah, to the 1/4. So yeah.
Well, David Shin erased. He's ready to go. He wants nothing to do with this.
David Shin is probably a little fed up with the last two problems. He wants something that he can handle in the time that they are given.
Still up 1-0. So he won the first, now 3 in a row that no one has been able to solve. Looking at his fans.
All right, ready?
And we'll see the next problem. Again, this is an easy integral. I should put easy in quotes.
Okay.
A definite integral from 0 to 1/2.
Both guys will at least figure out how to do this problem. I'm certain of that much. X equal to u squared might not be a bad idea.
So the qualifying round was a written test. It wasn't a face-off.
No, it was a written test.
Okay.
Yes, it was simply the same written test for everybody. Whoever performed better was invited to this final round. And I should restate that the gap between 10th place and all the lower places was fairly significant, which is why we chose to cut it off at 10. We didn't go into this with any set number of participants in mind. We figured something bigger than 8 and something up to 16 would be what we were looking for, and let the scores dictate what it would actually be. And that's how we settled on 10.
So Shrem has his expression and his limits.
Well, the interesting thing about this is if you factor x minus x squared, you'll get x times 1 minus x.
He's got pi over 3.
And this goes from 0 to 1/2.
There's a pi over 3 here.
Since it goes from 0 to 1/2,
He's wrong.
he is wrong. 0 to 1, you have x and you have 1 minus x. But from 0 to 1/2, that's symmetrical. I mean, x and 1 minus x, it seems like you can do something. Again, I'm just speculating out loud here. Some sort of symmetry might be promising here.
David Shin has tried 1 minus 2x equals y as a substitution.
Now he's got a sine inverse up there.
I don't want anyone else to think that
I still
Shrem
feel
is gonna go back to work.
not against the rules.
2 minutes.
I'm trying to think what the symmetry really tells the contestants here. But I can't really figure out if it actually does tell them anything. David Shin stalling here. He's got a chance to finish Suram off, but if he can't figure out what to do here, it's going to take us to yet another round.
I think he's going to try to evaluate something. See what it gets him. Just half a minute left. I think you're right. I think we're going to... Oh, he's going to circle pi over 2.
He's correct. Very impressive. It's the first time we've seen someone solve a problem correctly this late in the round, and David Shin upsets the #1 seed Suram Krishnan.
So Shen, a wild card of sorts, coming in ostensibly seeded 8th, but forced to do that first round.
Barely making it through that.
Boy, oh boy. He had that up there for a while, I think. He was fooling around on the right half of the board, and it
Now on the
David
last
right
leg
all
of
along.
the,
So David Shin
semifinal round, we have
coming
advances
through
to the
there,
semis.
and Liu.
making me look a little bit smarter with my prediction that he might be able to upset #1, although it took a good 4 rounds, and I think it had more to do with simply the problems not working out for Suram.
So the #1 seed comes away empty-handed, 0 for 4, so to speak, and our 4th and final quarterfinal match. You'll recognize one of these fellas, Lee Yu on the left.
And we've got Vijay Kumar's first appearance here.
Vijay Kumar seated #2.
I wonder how Vijay is feeling here. It's been 2 hours. He's been here for more than 2 hours, since all the contestants have been here as early as 5:15, I believe. And this is his first crack at actually going up here. I wonder if that's going to play into his favor or not.
It's 8 o'clock now. Remember, Lee Yu is one of the two who chewed through half a dozen or so integrals on that very first round. Lee Yu finally beat Ross Fu.
I sense some sort of chain rule or product rule, and yeah, I figured
that quickly.
somebody would get that one fast.
Vijay Kumar, the #2 seed.
Yeah, that's got to be right. When you get it that fast, you've got the 1 over log x, you've got log of x. So, I mean, the derivative of log of x has a 1 over log x in it somewhere. And I guess it would also have a 1 over x. So if you stick an x in front, it looks like things worked out. That will also, sticking an x in front will also help it actually separate so that there's something plus something else. And like I mentioned earlier, whenever you have the addition of two things with the integral, it looks like odds are there's going to be some sort of product rule in play.
Okay, so Vijay Kumar off to a very quick 1-0 lead, and here is one of the busier integrals we've seen.
Here's a factoring skills integral, in my opinion. You've got a little x-1 quantity squared on the bottom. On top, you've got, I'm not sure what you want to turn that into, but you will want to turn that into something. It looks very similar to x-1 quantity cubed. It's actually x-1 quantity cubed minus, or plus x-1.
Wow, Vijay Kumar has circled an answer again. Oh.
Ooh, I believe he just made us. He made a silly mistake somewhere.
He made a silly mistake.
Because, yeah, the top is x-1 quantity cubed plus x, or plus x squared minus x, excuse me, I had that wrong earlier. And the bottom is x-1 quantity squared. So you want to split the top up after you write it in that form, and then you just have a nice x-1 for the first part, and then you'll have x squared minus x over x-1 squared for the second part. So x times x-1 over x-1 squared, which is x over x-1. So now you've got to integrate x-1, and you've got to integrate x over x-1, I believe. And I don't think that's too tall of an order for Liu if he can get it to that point.
Hard to get a read on how he feels about this.
It does look like he's got some factoring tricks down to some extent here. Whether he has the right factoring, or at least one that will help him get the correct answer, is the question. Once again, it looks like he stuck some undetermined coefficients on there.
Vijay Kumar may be the man to beat here tonight, though. Very impressive first couple of rounds. I think just a silly error.
I suspect that as well, yeah.
Is all that kept him from advancing to the quarters in all of 40-some-odd seconds. Let's see.
Liu's really just gotta figure out what that thing actually equals, find a simpler expression for it, find what he thinks is the answer, and really just take the derivative of that answer. That's another interesting thing about integrals. When you've got time, you can always do this handy little thing, which is just taking the derivative of what you got and seeing if it's correct.
Right.
Now, on this stage, that certainly isn't going to happen unless one of the people is already out of this round.
And that's the surprising thing. If just a little strategy, Vijay Kumar up 1-0, has an answer he thinks in about 30 seconds. Facing the guy who took 6 rounds to get an integral, all you got to do is check over your shoulder and see where he is.
At the same time, I'm sure Vijay is quite confident in his skills, and he may have really just thought, hey, I've got it. Why take a chance at letting this guy, maybe I would be kicking myself if I was right and he got it. And he probably just thought I'll go for the kill here.
Fair enough.
I mean, one way or another, certainly both are viable strategies, and it really just depends on the contestant's perspective. At this point, I mean, even if Lee gets this problem, VJ will still be tied 1-1, and it's looking pretty good, at least from his performance so far. He's got a good shot to solve the next one, especially since it's a medium.
That's true, a medium integral, number 3 for the round. Lee Yu hasn't yet faced a medium integral. And it doesn't look like he's going to get this one because he's stalled out. It's only 30 seconds remaining.
I see a lot of E's on the board, which means that he got somewhere where at least he thought he should just be evaluating.
Yeah.
Since the limits are from E+1 to E²+1, he's been trying to stick those in and make it happen, but I don't know what exactly is preventing him from finishing this problem off. It's quite possible that he got an answer, thought it was right, then took the derivative and realized it wasn't, and now he's back at square one with 5 seconds left here, and looks like we will be moving on to the next problem.
Yeah, a line through your final answer does not signify victory.
So we will be moving on there. I'm surprised. Well, I suppose if Vijay Kumar had another crack at that, he would get that. And yeah, that looks kind of nasty with a lot of junk up there, but to be perfectly honest, that one came down to just a little factorization, and the form that I believe I cut it down correctly into is really just not too bad of a form to work with.
So we'll see the medium integral. We'll let Lee Yu erase his board. Get ready for the third integral of this round. This is the final quarterfinal match. These two guys looking to join David Shin, Yogesh Ramadas, and Taiji Hao. David Shin, the 8th seed.
Taiji, the 6th seed, and Yogesh, or no, not Yogesh.
Yes, in fact, all of those were, all 3 quarterfinals were won by the lower seed.
Indeed. All 3 quarterfinals were won by the lowest seed, and we don't have a single top 4 seed moving on right now. Although Vijay Kumar is in good shape thus far. Ooh, here's our medium. Quite interesting. He'll be he is
Kumar
done already.
Answer.
And is he right?
He's got tangent
I
x
didn't
plus
even
pi over 4.
I didn't even get a chance to look at that problem even, but he may not be correct. Once again, it's not the end of the world if Vijay gets this wrong. He is not in danger of elimination.
No word yet from the judges. They gave it to him.
He is correct. That is.
He had it in the other form.
He had it in a different form, but yes, indeed they are equivalent. Wow, that was really impressive there. Vijay Kumar came out and just handled business pretty much.
Well, so Vijay Kumar, definitely the man to beat. We'll be right back. This is Sportcast at MIT with the MIT Integration Bee. And welcome back to MIT in the Green Building, 54100, the famed MIT Green Building, 21 stories tall on the MIT campus for the 2006 MIT Integration Bee. We started with 10, we're down to 4. 4 finalists, semifinalists, I should say, at the MIT Integration Bee. Vijay Kumar, who's the man to beat, Taiji Hao, David Shin, and Yogesh Ramadas. So we're going to see David Shin and Yogesh Ramadas here at the board with their first integral. Now this is the semifinal round, so we're going to go medium, medium, hard, medium, medium, hard, and so forth. And I believe it's the first to 2. So the first to get 2 integrals will move on. David Shin on the left.
This doesn't look too terribly bad at first glance.
Yogesh Ramadan on the right.
David Shin pulling out a triangle there.
Yogesh Ramadan countering with the inverse hyperbolic cosine.
That's a problem solver there, trying to turn an integral into a geometry problem.
Yogesh Ramadan has circled an answer. I'm sorry, Ramadas, excuse me. Yogesh Ramadas. He circled an answer. And did he have a -0 at the end?
He did have a -0, but they're not going to punish him for that alone. Although that is an amusing and fitting way to represent how much I guess, pressure they are under up there.
So what's the verdict? I don't. Nope. The clock's
Clock
restarted.
is ticking.
I will say that the integral from 1 to root 3 with the square root x squared minus 1 feels very geometric.
Yeah, with 1 over the square root of x squared minus 1, well, if you just let one of the legs of the right triangle be 1 and the other one and the hypotenuse be x, then 1 over square root of x squared minus 1 is simply the tangent, I believe, right there. And you just got to figure out what limits to put on. You've got x going from 1 to root 3, and at 1, well, if x is 1 and that's supposed to be the hypotenuse, then you've really just got a degenerate triangle there. And then if it goes up to root 3, well, you've got 3, 1, and you can fill in the blank there, 2 root 2, I suppose, and then make the geometry work out. So it will be interesting to see if David Shin's initial instincts do indeed lead him to a correct answer.
Approaching the 2-minute mark.
Again, each time David Shin's had plenty of time, he has taken his time, and so I don't expect to see a circle too soon, at least. I suspect he will most definitely check his answer, although I'm not sure how easy it will be depending on how he interprets it geometrically. Yogesh seems to have brought something up to Ross Lippert.
Reconsidered their life. And your answer's right.
And they have
Oh, look at
reconsidered
this.
Yogesh's answer. I
Look
guess
at this.
it was in some equivalent form, I suppose.
That or the key was wrong. So Yogesh appealed.
Our Koch, in terms of like natural log, so you feel like
You're just replacing one thing with another thing. If the answer were 5 or,
so
10 or something like that, then that would
so yeah.
So the two answers were indeed correlated, and that also shows how tricky this can be sometimes. Even with an answer key, we've had some issues, and I don't think it's completely the fault of the answer key. Many things in mathematics can be expressed in similar forms, multiple similar forms, or by similar I mean equivalent.
So Yogesh Ramadas does indeed take that first point. He now needs one more to survive.
Here we have another
That was
medium.
that was a medium, and this is a medium.
Here's a problem that I actually wrote personally and remember quite well because I thought it was pretty interesting. A geometric approach to this problem would work out. I wonder if that is what they'll notice. The value of sine inverse of cosine of x comes out to something fairly reasonable in terms of x. Another thing you could probably consider is just sticking something in to make the sine inverse go away. Although I'm not sure how exactly that might work out.
Yogesh Ramadas has circled pi over 2.
That might be right.
be an easy call, judges.
No, it's not correct.
Ooh, he's off, I think. I think the answer is pi over 4 or pi squared over 8 or something. Just throwing...
Well, boy, things have accelerated, though. Yogesh Ramadas and Vijay Kumar just
they've
moving
been-
at a different pace
they've
from
been
the rest of the
hurtling out.
competition. So David Shin's going to get another free 3 minutes here to, well, maybe.
Maybe.
We'll assume the appeal won't carry the day this time.
Yogesh looks like he will try at least. But the answer, and he is shaking his head. I think
Yeah.
he's discovered his mistake. To evaluate sine inverse of cosine of x, it is really just treating x as an angle and thinking that, well, cosine of x is basically that one leg over the hypotenuse. And, well, what is the sine inverse of that? Well, you really just want to look at the other side. And it's going to be interesting to see what this comes out to for David Shin, at least. It doesn't look like David Shin has tried anything geometric this time, although that certainly isn't the only approach. And he does appear to have it in some fairly simple form. 2 sine z plus cosine z, is that what I believe he has written there? So it's going to come down to seeing if he thinks that's correct or not.
Less than 2 minutes now for David Shin.
David Shin does look a little bit lost here. again, cosine of the angle, well, if you think of the legs of a right triangle as A, B, and C, or the hypotenuse being
Here
C.
comes the triangle.
Here is the triangle. Well, cosine of x is a over square root a squared plus b squared. And, well, sine inverse of a over square root of a squared plus b squared is just going to be the other angle. It's going to be 90 minus x. And since it's going from 0 to pi over 2, it really doesn't seem to matter that much. So it looks like, at least I believe, it's just pi over 2 minus x is what this comes out to. You got to evaluate it from pi over 2 to, from 0 to pi over 2, which, we'll see if I got that right, or I might have, I think I mixed up a sign in there somewhere. But that is the general idea of what you want to do. David Shin did draw a triangle.
I'm surprised he's not getting this.
Yeah, he does have the triangle up there.
He's just going to go for it.
He's gonna
Pick your denominator, David. 4. That's his choice.
It's pi over 2 minus x. And the integral, yeah, it's pi over 2x minus x squared over 2. I had that. Pi over 2 minus x. The integral of that is pi over 2x minus x squared over 2. Evaluate that from 0 to pi over 2, and yeah, it was pi squared over 8.
A little gamesmanship by David Shin, but to no avail.
Well, the fun continues.
I like
here.
that problem.
Here we have our first x.
Okay, so it's a new territory for the integration bee.
Audience responds with maybe a little sarcasm right there. I think that we've had plenty of hard integrals so far. It will be interesting to see how this one plays out.
Extreme. So the clock is juiced up to 5 minutes.
I do remember a problem that had to be pretty hard to be marked as extreme. And by pretty hard, I mean I could see the answer and it was still looking pretty hard.
So here's our first one.
Log of sine of x. Ooh, and this is from 0 to pi over 2. I don't think you can do this problem without using symmetry. I really don't think you can do this problem without using symmetry. And I think that log of sine of x from 0, the integral from 0 to pi over 2 is, well, equal to the integral from 0 to pi over 2 of log of cosine of x, simply because I think they just go in opposite directions. And then, so if those two are equal, then if you can just add them, and you'll get something maybe a little nicer. I'm not even sure if that's the right thing to do. I'm totally stumped here as to what this might be, and I really do believe that it's going to require a symmetry argument to get this problem.
Well, this one has slowed both of the contestants down.
Either guy seems to be able to think of anything they can do, and I don't blame them.
Sort of toying around with the problem stage more than anything. 4 minutes still left, but they're thinking and doodling more than computing.
Again, the area under the curve of sine of x from 0 to pi over 2 and cosine of x from 0 to pi over 2 are the same. One simply goes from smaller to bigger, and the other one goes from bigger to smaller. So taking the logs, the area under the curve will remain the same. The question is simply now how to use that fact. Log of sine of x plus log of, well, log of sine of x equals 1/2 of the quantity log of sine of x plus log of cosine of x. And, well, I guess evaluating that log of sine of x plus log of cosine of x, that comes out to log of sine times cosine of x, which comes out to log of 1/2 sine of 2x. So now you've got that 1/2 of, well, now you've got that the integral of 1/2, or log of 1/2 sine of 2x is twice of the integral of log of sine of x, and I suppose from there, wow, this is really something. 2.5 minutes have passed almost, and it doesn't look like either guy has any idea what to do, at least thus far.
In order your announcers, just to let you know,
Yeah,
you're watching the MIT Integration B. This is the first of 2 semifinal matches. Matt DeBurgalis with Albert Nee, bringing you live and without commercial interruption. And I should mention in high definition, the 2006 MIT Integration B. We've seen 10 competitors Now we're down to 4. We have 2 semifinals. This is the first extreme integral that we've seen tonight. Extreme is the hardest of the 3 categories. We've seen some easy integrals, which are anything but, really. We've seen some medium integrals that have posed
Probably
significant
also
problems.
anything but.
But this one is in a different class, and these 2 guys who work very quickly typically have just stalled. Really not sure what to do.
Really looks like this problem definitely deserves its extreme category, as well. We've had some hard integrals earlier on, but nothing that is really just totally stuffed 2 guys that have shown to be quite proficient at solving integrals thus far tonight.
Take this opportunity to remind you Sportcast is a project sponsored by the Student Information Processing Board at MIT, as well as Information Systems and Technology, with additional support this evening from the MIT Department of Athletics and the MIT Department of Mathematics. Probably an unprecedented cooperation and collaboration between those 2 departments.
Indeed.
1 minute left. This is a 5-minute problem. We're giving 5 minutes to the contestants for the extreme integrals, but it
Doesn't look good.
It looks like all the time has just been puzzlement and thought, and I don't see any signs of a last-minute solution from either of these fellas. "30 seconds now remain." The other thing I was thinking, you look up at that integral, and as long as you're looking at the integral, there's this extraordinarily distracting clock. I mean, the clock's ticking, which is bad enough, but then there's this little animation of this guy drawing on a blackboard.
And scribbling out his work, which has happened quite a bit on the real blackboard as well tonight. David Shin seems to have called it quits. He's just staring at the clock, like you said, and the integral itself, and really probably just wondering how you're supposed to do this problem. Yogesh, as well.
So let's see if the judges give us a sense of how to approach this one.
Let's see if James says something. He may not want to, because it may give away a little bit of the... It may give a hint as to how to do some future problems.
Just quiet defeat. Pi over 2 log of a half.
No murmuring, and it does not look like too many people have too much to say about that problem there. Going back to a medium here.
Clock's reset to 4. We'll have a medium integral.
Which,
remember, after that appeal, Yogesh Ramadas is up 1-0. He had it correct, but he expressed his answer in tangents, and the judges expressed theirs in sines and cosines. So he does have a 1-0 lead.
got some goofy stuff right here. We've got sine plus cosine on top, then 9 plus 16 sine of 2x on the bottom. What will they think of next? We've got these perfect squares in front of, well, we've got these perfect squares on the bottom. How that plays out will be critical to how this problem plays out.
Yogesh doing a lot of thinking. Both contestants now doing a lot of thinking.
Again, not much going on here.
That extreme integral might have taken all the juice out of him. I don't know.
Indeed. The thing is,
Well,
sometimes
there's nothing.
sometimes when you see a hard problem, it just makes everything look that much harder afterward. Both guys with no idea how to approach this.
Clock passes the 3-minute mark. Now, no, he's erasing. Let's see if he does any work. Oh, I don't think we've seen this yet. Neither contestant has really written anything of significance. They're not even doodling.
Both guys really staring down the 9 and the 16 would certainly catch the eye, but what to do with them, not obvious at all. Again, one of these goofy fractions that really don't seem to lead anywhere at first glance. 0 to pi over 4 once again. Not sure if that actually means anything. probably makes things a little bit simpler in terms of answers, since sine of 2x will go nicely from 0 to pi over 2, and sine of x plus cosine of x, well, that's symmetrical, so it doesn't really make too big of a difference.
Minute and a half. Yogesh, interesting tactic. He's going to go with the symmetry argument and answer 0.
I don't think that can be the answer.
Seems like it's all positive.
Yeah, once again, it stays above the axis, the x-axis the entire time.
A little too cute, but I like it because
at this point, yeah.
Figures what the heck.
If I was David Shin, I would throw out something involving pi and just hope it works out at this point. 9 plus 16, 2x. 16 sine of 2x is, well, going to be significantly larger than anything sine of x plus cosine of x ever reaches. The maximum of sine of x plus cosine of x is well less than 2, whereas the minimum of 9 plus 16 sine of 2x is going to be 9. So we've got something that stays strictly less than 2/9 on this interval 0 to pi over 4. So if you multiply that out, you've already got yourself like an approximate upper bound for what it could be. So 2/9 times pi over 4, well, that is pi over 18, I believe. 2/9 times pi over 4, yeah, pi over 18. So it's going to be less than pi over 18, which is quite small.
That's David Shin's approach. He's going to write down something. I don't think he's small enough. I can't tell what he wrote in the denominator.
Yeah, it doesn't look small enough. It's 1 over 20 log 3.
Wow.
Wow.
So a couple of inscrutable definite integrals.
It's really something. I don't know how that...
I think we're numerically close.
I don't even see how that comes out to what they ended up with.
Hey, let's see what happens. Another medium integral, 4 minutes on the clock. Here it is. A little more room to work with, I guess, this time.
Ugliness, though, is the initial response here. Got 1 minus x times the square root of 1 minus x squared. Now, every time we've seen some junk like that, it's really just come down to some sort of it works out nicely and just happens to be the derivative, or yeah, just happens to be the derivative of something, some goofy combination of elementary functions. I'm not sure if that's going to be the case again here.
With each successive problem, they've written less. Now we haven't even touched the board.
Both
30
guys,
seconds gone by.
I agree that both guys have definitely seemed to have felt the impact of the last two problems. You've got 1 minus x to the 3/2 on the bottom and 1 plus x to the 1/2 on the bottom. That's basically what it comes down to. And so you've got the negative 3/2 power effectively and a negative 1/2 power, but they don't really correspond to the same thing either, so it doesn't exactly help too much. At least a little writing on the board here, but really not much at all.
Now, we've seen some of these mediums get solved in seconds, but maybe it's the luck of the draw, or maybe it's that extreme integral taking its toll. Either way, the last 3 rounds have been very different from what we started out with.
Yeah, most definitely. I believe the medium integrals have a very wide range of actual difficulty. The extremes are indeed extreme, and well, the easies are at least usually a step below the mediums, and here we're looking at least one of the most intimidating mediums thus far. Still no action whatsoever.
Wonder if fatigue's a factor. David Shin's gone through a couple rounds already.
Certainly.
Everybody's been here for a few hours.
Most interesting part of this is the next problem is another extreme. The integral's made slightly bigger on the screen. Not sure if that's going to do anything at this point.
Integrals have been typeset with LaTeX. LaTeX, of course, is the system of choice for most mathematicians laying out expressions of this sort. You have that characteristic computer modern font with the italics.
Yes. LaTeX has always been a very professional looking, if nothing else, typesetting program, and that's probably what's made it so popular among mathematicians. Well, the organizers did suspect that the semifinals might be a little hard, and so after this extreme, there won't be another extreme, regardless of how long this thing continues to go.
Oh, I hadn't noticed that. You're right. So we only have 2 extremes and then just mediums.
The extremes max out at 2 in the semifinals, but in the finals, we're going to start off with an extreme and alternate between mediums and extremes, and yeah, this one's done.
So the clock expires.
Or will be in just a couple seconds.
And let's see what it comes out to here.
Both guys resignedly erase their boards.
Oh.
Again, if you take something fancy, but not altogether too ugly, and just take the derivative, odds are you're going to have a pretty tough integral. Oh, it looks like somebody has an explanation there for how you might have gotten that. Pretty impressive if you ask me there. Sit there with really no pencil and paper and plug that one out.
So I don't know that this is an extreme. I can't tell from the
clock is still set at 4 minutes.
And looking at the scroll bar on that web browser.
It looks like they kept with the mediums, which may have just been an impromptu decision.
Okay, well, David Shin working quickly, at least for a moment.
You've got this
Yogesh
4th root of x
thinking.
plus 1, and then to the 10th power of all things. Again, at a certain point, you have to wonder, how hard can this really be? Because it just can't be incredibly ugly, and yet there's a 10th power on some sum, and it's in the denominator. I mean, what am I supposed to do?
Now, how would a tool like Mathematica fare with something like this? Are these all...
Personally, I don't have too much experience with Mathematica and don't know, but I do believe it would do pretty well. A lot of these integrals, even some of the harder looking ones, can indeed be integrated by the TI. The TI-89. But some of the harder ones definitely cannot be integrated by the TI-89, as we discover in our own adventurous evaluation of how good calculators really are at doing integrals. Especially, say, one is that symmetry one earlier, which certainly cannot be evaluated, because that requires a trick that really is, if anything else, human ingenuity.
Thinking outside the box.
Exactly.
So let's see.
We've got some progress here. Both guys have gotten somewhere, it seems.
There's nothing quite like the feel of chalk on a chalkboard for doing mathematics, though. Very
Indeed.
satisfying tapping sound.
Both guys getting going here for the first time in 3 problems. Or 4 this is the 4th problem now. It's the first time. Both guys seem to have discovered something. Can't quite see what it is.
He's going to circle it. Oh,
Yogesh.
oh my. Now here's this. David Shin finished his circle first, I think.
Both guys
But
circled.
Yogesh started his circle first.
Both guys circle at the same time, but I don't think they have the same thing.
Well, that'll make it easier to sort out. Wow. Closest finish we've seen so far.
By far.
That's a 32. That's a 1 plus 4th root of x to the 8th. That's a 36, and that's a 1 plus 4th root of x to the 9th.
So Ross Lippert coming out to be the arbiter of what's been written. Haven't heard a decision about whether it's correct or not.
David Shin eager to get his answer evaluated. It looks like they have moved on to him.
Well, if nothing else, we've saved some time.
Ooh. Looks like David Shin was reasonably close there. Haley's had some of the powers looking right there.
Wow.
Well, the encouraging sign is both guys got somewhere. I'm sure that's good for them in a psychological sense as well.
Absolutely.
To have finally seen one where at least they were able to get somewhere. There's really nothing worse than just staring at something. As time goes by, the odds of getting something that you have no idea for, it just goes down so fast simply because the psychological pressure of just, wow, this problem is better than I am, in a sense. Well, earlier we had log of sine x. Here we've got sine of log x, showing that maybe it's not that hard to write hard integrals, since it looks like the organizer's just deciding to switch them back and forth. At least I know I've done that a couple times, and sometimes you get surprisingly different answers and surprisingly different difficulties.
Both moving quickly. David Shin's on your left, Yogesh Ramadas on your right. Yogesh has a 1-0 lead. If he gets one, he moves on to the final round, which may be a curse more than anything, but
David Shin eager to try to get a point back here.
the final round will start with an extreme and carry on. Okay,
Yogesh
we
with
have
a
an
circle.
answer. We got it.
Correct.
Yogesh Ramadas is our first finalist at the MIT Integration Bee. David Shin, hard-fought battle, takes a seat. Had the fan support early.
An impressive route, really, by David Shin. He had to win up first to 1 because of time constraints early on. And then he was able to knock out the #1 seed in
Oh yeah.
with 2-0. And again, David Shin is not completely done here. Or
That's
no,
true.
he's not completely done, indeed. He'll be going on to the 3rd and 4th round match.
So the way this will work is we have a second. Well, let's hear what Ross has to say.
Because it's going to go VJ and Tage, then the runner-up, and then the final.
Okay, so we're explaining the same thing. So we're going to have the second of 2 semifinal matches now. This is going to be, let's see, Vijay Kumar, who just came flying through the first round
Against Taiji.
against Taiji Hao.
Yeah.
Then we'll have the 3rd place match. This will be between David Shin and the loser of this match. Taiji coming up to the board on your left, Vijay Kumar on your right. And then finally we'll have the championship round. So this round, as with the other semifinal, is going to be medium, medium, extreme, medium, medium, well, possibly mediums for the end. I don't know how they'll play that, if they'll throw an extreme in here.
At this point, I've got to imagine fatigue is starting to play a role for everybody. David Shin's been up there for many problems. A couple other guys have been up there. Vijay actually hasn't been up there too long.
No, he's really not been up there for more than a minute and a half.
He didn't make his first appearance until, well, the 8 o'clock mark, and now it's only 8:30, and he's only back up there for the 2nd time.
Okay, a bit of a false start. We saw that one already. So this will be a medium.
Here we go.
And there's the problem, 0 to pi over 2 of 1 over 1 plus the sine of x.
This I don't believe is too hard. You multiply top and bottom by 1 minus sine x.
Kumar working quickly. That's exactly what he's done.
He's got 1 minus sine x over cosine squared, and then at that point you got secant squared and tangent secant. So I mean that's very good. Secant squared and tangent secant are very similar doohickeys right there. And it
He
looks
wants to evaluate. Let's see. I don't know if
he's already
checking
got
or
it,
if
yeah.
he's not
Because
happy
the
with his
integral of
answer.
secant squared is tangent, and the integral of negative tangent secant is secant. So he's really just got to evaluate tan x minus secant x right now, and he's having a little trouble with that.
3 and a fraction remain. VJ
trying
is
to figure out what
just
to do
stuck
with-
in his tracks.
He's trying to figure out what to do with that tangent of pi over 2, which doesn't really work, and I'm not sure if the organizers realize that.
Perhaps there's a problem with the problem, or is there another approach that avoids that?
Or it
I
cancels
mean, if that's the
itself
form,
out.
yeah, there you go, because there's a secant. Let's see.
Yeah, indeed. I mean, yeah, secant will cancel that out because you've got secant is, well, 1 over cosine. So you've really got infinity minus infinity, so it's got to be evaluated in some other way here.
Okay, he's going to go with 1. He circled it. He
He's
got it.
right. Vijay Kumar, really.
He got it, boy.
He got stalled there a little bit by that little tangent of pi over 2, but then he realized that secant of pi over 2 makes it altogether still reasonable. And wow, yeah, Vijay Kumar is just burning through these problems.
Okay, this will be another medium, 4 minutes. There's the problem.
Very interesting looking problem. You've got 5 squared on top, you've got 3 and 4 on the bottom here.
inside a square.
Exactly. Yeah, inside a square. So, I mean, everybody's familiar with 3, 4, 5. How exactly does that play into this problem? We will have to wait and find out.
Vijay Kumar on your right just needs one more solution to move on as the second finalist. He's circled
He's got
an
a
answer.
circle.
Let's see what the judges say.
Vijay Kumar, a little gamesmanship there, blocking off his side of the board. That was very fast. Whether or not he was... It is not correct.
Judges, is it right or wrong?
It's correct.
No.
Judges are having a little trouble here. I think once again we've got an equivalent form here.
Kumar likes the tangent. It seems to confound the judges' version of their answer.
If he is indeed wrong, this is time for Taiji to really...
Yeah, Taiji could be well, no, he can't be working, but he can be thinking.
But yeah, indeed, he can be thinking. He can be staring at what he's doing. He can be staring at BJ's side a little
Nothing
bit.
stops him from moving, I guess, to get a better angle. Still waiting for word from the floor.
I wonder if the 4 organizers that are still out there right now bothered to bring a TI-89, because that might not have been the worst idea.
They're not going to give it to him. The
They're not
clock's
giving it to
restarted.
him.
So Taiji, probably with a rare opportunity for some quiet time with his integral.
Whether or not it'll pay off, it's left to be seen. What this problem really is it's 5 over, at least in my eyes, it's 5 over 3 cosine x plus 4 sine x, all of it squared. And that's what I would be looking for, is how to make something happen with 5 over 3 cosine x plus 4 sine x. So, I mean, if you set up the 3, 4, 5 triangle, well, cosine of x and then sine of x, those both will correspond to the same, yeah, they will correspond, I mean, to the same angle there.
2 minutes. Taiji having a tough time on his side. He had that opportunity, but I don't get the sense that he's going to be able to work through this. Vijay Kumar preparing his board for the next round.
Which will happen one way or another.
That's right. Minute and a half now for Taiji. Taiji, the 6th seed, advanced by beating Bobby Liu in an upset of sorts. Though, as you said, the seeding is
pretty
not
close,
necessarily indicative of any particular ordering.
Indeed. Cosine x, 4 sine of x. Very interesting.
Less than a minute.
I wonder if multiplying top and bottom by some cosine minus sine of some sort might work out actually, or cosine minus sine quantities squared.
He circled an answer. He did some work at the end, but
negative 1/4 times in parentheses 25 over 3 plus 4 10x.
It looks like he is correct.
He's correct. Boy.
Very impressive.
So we are 1-1, right?
Started
one-one
writing
tie.
with about 30 seconds left. Didn't look confident at all. But he's correct. He ties the score at 1 apiece. Vijay Kumar now. Let's see here.
Guess that was the answer.
There's the answer.
And just keeping along with the pattern from the last.
Kumar again favoring the tangent form, though this time he was off.
He's got this. He's got the extreme coming up though.
Thank you.
Okay, so we'll set the clock to 5. And here is the second extreme integral that we've seen this evening. Vijay Kumar is first.
Yeah, that does not look
It's
pretty.
an
at
extreme
all.
integral.
E to the 3x minus e to the x. This is going from 0 to infinity. You got an assortment of things on the bottom there. You can factor out e to the x from the top, and you end up with e to the 2x minus 1, so it becomes e to the x times e to the x plus 1 times e to the x minus 1. So you can indeed cancel out the e to the x plus 1 at least. So then you get, well, e to the x times e to the x minus 1 all over x times e to the 3x plus 1, and I'm not sure if that's really any better. Both guys have written some stuff down. This isn't the total stonewall that the first extreme was. But whether or not that means either side will actually be able to produce a correct solution remains to be seen. Vijay Kumar has been so fast every single time here. Indeed, this does look like it's an extreme. And the fact that Vijay Kumar hasn't gotten an answer out in less than a minute.
Now we'll go back and put some limits in. That's not going to help Vijay. He did a substitution. Is it e to the x is t?
I'm not quite sure what exactly he did. I cannot tell from here, but he seems to be trying to integrate. Maybe he seems to have tried to split it up somehow. It does look like he has reduced it. Yeah, it does look like he has reduced a lot. And
0. He's answered is 0. 2 minutes 54 seconds
Well, that's
left.
either right or wrong. And he is wrong.
Correct.
So again, Taiji's got time. If he can pull this out, he would come up with what I would say is an upset.
I would agree.
Vijay Kumar, not only has he been winning, but he has been winning in very impressive fashion.
It's that trade-off with speed versus correctness.
And it looks like that trade-off may be what spells the end for Vijay Kumar.
As the rule would be, it's important to be correct. 2.5 minutes. Let's see, Taiji didn't look like he had much going on last round, and then he came up with the answer at the end. So we'll be patient. We'll see what happens. He's been thinking for most of this one. This is an extreme, so 3 minutes have gone by.
He pulls. He factors the top, gets it into that form, which is a little bit neater at least, because it cuts off one of the elements of the denominator. At this point, I'd say you factor e to the 3x plus 1, because that's actually a sum of cubes sum of cubes in disguise. So then you get e to the x plus 1 again, and then also e to the x minus, or e to the 2x minus e to the x plus 1.
Minute and a half. Vijay Kumar isn't bothering to erase his work. I feel like he got far enough along and then thought he had an insight about terms canceling or whatnot, and just went with the 0.
Not sure if that was the best idea on an extreme, because at least thus far there haven't been many results on these. Although I'm not sure the contestants are altogether completely aware of which type of problem is being put up either. They might be paying attention to the scrolling up top and the time differences.
You know, Vijay Kumar is going to go have a conversation with the judge. Now, it's hard to imagine that 0 is in a different form from the answer they had, but
at the same time, I guess it would be possible for the answer key to be wrong.
Ross
on an
Lippert
extreme
comes
integral.
over. It looks like Vijay Kumar looked at the problem again and felt more comfortable with his answer. So we've seen this happen once before. Maybe not this time, though. 25 seconds left.
Taiji doesn't have much.
It's the time to move is now if he's going to do it.
On the plus side, this is a definite integral, which makes guessing quite a bit easier. You at least have a chance in my eyes.
Might as well go with 1, right? I mean, E.
Doesn't look like Taiji's going to do anything, though. Time will run out.
Okay. Log 3/2.
Wow.
So be it.
So be it, indeed. One of those if you say so's.
A quick conference among the judges. Might be a question of time at this point. It's let's see, it's just past
8:45.
8:45. Yeah, so we've been here closing in on 3 hours. We still have the runner-up match for 3rd place and then the championship match, and that's going to be loaded down with integrals that no one has been able to make headway against.
It might be watered down if necessary, if the guys continue to fail to solve.
So here's the next one. Definite integral from 1 to 2.
This is a speed problem.
Both contestants have a point, as you say, with a speed problem.
I would imagine Vijay Kumar has the advantage here.
Could come down to an error, could come down to just who moves faster. Vijay Kumar.
Looks like he's already evaluated the integral itself. Sticking some roots there.
Taiji is making progress on his side.
I think the pressure's really on after having such tough integrals to realize that this one probably will be decided somewhat by speed. It's got to be quite a shock for both contestants. Taiji's slowing down a little bit. Vijay Kumar's got the 1 and the 2 he's evaluating at this point.
I wonder if he'll check his answer, or if he'll at least look over his shoulder. This is an integral you don't want to get wrong with 3 minutes left.
Definitely not. I think Vijay Kumar is at least taking a little bit more slowly this time after making some mistakes that I'm sure he didn't expect.
I get that sense as well.
Now he's standing there, hands on hips. It's a little bit surprising. I think he's trying to figure out where his mistake is at this point.
2.5 minutes. Hard to tell where Taiji is. I see him trying to evaluate something, possibly with a substitution, because looks like a 0 at the bottom, but far bottom right of his board. He writes very small.
Does look like he performed some sort of substitution.
Two minutes. Vijay Kumar back on track with some work. Now slows down again.
I'm surprised an answer hasn't been produced. There's
Okay,
a circle.
Taiji circled an answer.
Whoa. If he's right, that would
Minute
be
54.
1/2 times in parentheses 2 square root of 3 minus natural log of absolute value of 2 plus square root of 3.
That's right. That's correct. That's right.
Wow.
He is correct, and he knocks out
Taiji
Kumar.
Howe knocks out Vijay Kumar and moves on to the final round. So
Very
our
impressive.
finals are set. Taiji Howe moves into the finals.
Yogesh Ramadas.
And Yogesh Ramadas.
So the 5th and 6th seeds.
I think we have to consider that an upset. I think Vijay Kumar came into this thing and just
Yeah, he was
established
on
himself
fire.
as the guy who's going to...
It is time for the round for runner-up.
Okay, so
Now
we'll
we've
be
got-
back in just a moment. This is MIT Sportcast. We'll have the runner-up round for you. Actually, we're going to stay with you. We're going to stay with you for this round. Then we'll take a quick break and come back for the Grand Championship round. So this is the runner-up. This is for third place. On your left is going to be David Shin. David Shin had that fan base, the shirtless fellas, the other people with him. Fourth row here in 54-100. On your right, the just defeated, bit of a surprise, Vijay Kumar came in seated second. David Shin, quick test of the chalk.
We're going
So, yeah, what's the story?
We're going MXMX here, which means it's going to start pretty hard and going to get very hard.
And it's the first to two. So this is a medium. David Shin, the crowd favorite of sorts, but Vijay Kumar probably the favorite. We'll see if losing in that semifinal knocks him off his rhythm a bit.
This is a reasonable integral to do. It seems like expanding sine of 2x will lead somewhere. David Shin's got an answer, it looks like. Yet to be circled, though. Vijay Kumar scratching his head. Something looks like it went wrong for him.
He made a substitution.
All of a sudden, things no longer falling right into place for Vijay Kumar.
Now the winner of this has a prize. We don't know what the prizes are. They're going to be announced. But the winner of this, third place, is going to have a prize.
Vijay Kumar now erasing. David Shin also looking quite hesitant with what he's got.
Maybe this one's a bit trickier than it seems.
Yeah, I definitely agree with that. Seems as if even if you split it up, say you've got square root of 2 sine of x cosine of x, and so if you just split up the top, all of a sudden you got a little square root sine over, well, it would be square root sine over square root 2 cosine. And then you'd have square root cosine over square root 2 sine, which is what David Shin actually has right there on the board. But what to actually do with that is the question.
Okay, Vijay Kumar has circled an answer.
That is correct.
You got it. A little more deliberate pace this time, but he gets the first round. So Vijay Kumar up 1-0, and one more correct answer for Vijay Kumar, and he will be the third place contestant this year.
Be very impressive if he gets it on this one, simply because no one has gotten an extreme thus far.
I'm not sure we have an extreme.
Does not look like it.
Okay, so we're going to go with a medium, probably to save a little bit of time.
Probably was the decision, and I guess the extremes will be saved for the final round. I'm sure we'll see at least 1 or 2 of those in the finals.
So David Shin on his last legs. He's drawn the triangle. Nothing to be ashamed of with a loss here, though, of course. I mean, the guy is the 4th best integrator at MIT. He could do worse.
Certainly you can, and David Shin has done quite well. He's done some impressive stuff tonight. He's really just run into a lot of people and had to do a lot of problems, and I'm sure as time went by, it took its toll on him too.
Well, what's going on here? Vijay Kumar circled something with theta in it and then erased the circle.
Quickly erasing it, of course, that couldn't have been right. Now he's made the substitution x equals tangent theta, which makes sense since tangent squared plus 1 equals secant squared, so the square root of x squared plus 1 in that case would just be secant. But if x equals tangent theta, dx is going to equal secant squared theta. So then you've got some interesting stuff. You've got secant squared theta over tangent theta plus secant theta. And what that actually plays out to, looks like Vijay Kumar's having...
It plays out unfavorably, perhaps.
Might be, as he just took a glance at the clock and now is once again standing there. David Shin also not showing too much movement here. Both guys looking at the problem a little bit, looking at the clock a little bit, looking at their stuff a little bit. I do think that Vijay Kumar was on the right track. I'm not sure exactly why he erased everything.
Well, he leaves his original substituted version up.
Approaching a minute here.
Another bit of work that Vijay Kumar erases on the right. David Shin starting to accelerate his writing. He circles it. So David Shin has circled an answer. Remember, he's down 1-0, so he needs this to stay alive.
He has a cinch inverse in there. That's going to be a doozy for the judges to try to see if it's equivalent.
No, they don't give it to him.
They're not giving it to him, yeah.
Vijay Kumar will have another 40-some-odd seconds to work on his answer, but you don't get
David
any
Shin
indication that he knows what he wants to do.
David Shin started to erase. He might have thought better of it. He's looking over at Vijay right now. He might be keeping it up because he thinks he might still have some hope, or maybe
not.
Maybe not, because there it goes.
20 seconds left.
15 seconds.
Head scratching. That's not a good sign at that point. Looks like
No.
Vijay Kumar.
We're gonna go to a third problem. Show us the answer, judges. Oh, look at that. There is an inverse hyperbolic sign in there.
David Shin's trying to figure out where he was wrong. Oh, he was barely off. He had that one half basically in the wrong spot.
Oh, that's a bummer.
That is a bummer, because that's not a pretty answer, which means David Shin really, once again, showing that he certainly has quite a bit of skill. Came really close on that one.
Okay, Vijay Kumar smiles, figures he's got a new lease on life. He does his usual very deliberate erasing of the board. There's another medium integral.
Earlier we had like square root x squared minus 1. Now you've got square root of 1 minus sine of 2x. I mean, once again, these are pretty simple looking integrals in terms of, well, there's not too much there. It's not like some of the messes that we've seen so far, and yet it doesn't look like it's going to be too easy to solve this one. Neither guy with too much so far. The 1 there, well, if it was a cosine 2x, the 1 would be welcomed, because you would be able to find a way to get it to pair up with something that cosine 2x can turn into and eliminate itself. But with the sine there, at least at first glance, there's not too much you can do, it seems.
Vijay Kumar has circled a piece of his answer. There's a plus minus in front.
David Shin also circled something.
Oh, he did.
BJ circled first, though.
I didn't catch his circle.
No, wait, but I didn't completely circle it.
David Shin says he hasn't completely circled it.
Yeah, I mean, this depends on Limits of integration.
Yeah, that's true. Yeah, that's correct.
That is correct.
Okay, he's got it. Vijay Kumar.
Impressive
Vijay Kumar
display.
is our third place contestant in the 2006 MIT Integration V. Vijay Kumar came into the tournament seeded to upset in a sense in the semifinal round, but redeems himself and emerges in third place here at the MIT Integration B. So we're going to stay with you. There's no commercial break. We're going to go right into the final round. This is it. This is what we've all been waiting for. Number 1 versus number 2 in the final round at the MIT Integration B.
An impressive display as well by David Shin, who's the only person who managed to climb out of the bottom 4.
David Shin started the game seeded 8th. David Shin defeated
Ksenia.
Ksenia in the first round. That's right. Boy, that seems so long ago. Then Shriram, the ostensible number 1 seed. And then Yogesh Ramadas. So
we've got
David
the
Shin in
final.
4th place. Vijay Kumar in 3rd place. Kumar beating Lee Yu. And then losing to Taiji Hao.
It looks like they started them off with a medium.
So Taiji Hao on your left. And Yogesh Ramadas, I'm sorry.
Yeah, that's
Yes,
it.
Yogesh Ramadas on your right. I think I misspoke earlier in David Shin's. Forgive me, the bracket that's been drawn here is the most bizarre tournament bracket I've ever seen. Three minutes left. Now on our paper, this is first to 3. I don't know if that's still the case.
Yeah, it may not be the case. We haven't heard any word from the crowd, but again, the entire B has lasted quite a bit longer than I think anyone expected. For this specific problem, I would imagine multiplying top and bottom by cosine minus sine would lead somewhere at least. The bottom would turn into cosine 2x. The top would turn into cosine squared minus, well, 1/2 sine of 2x. It's not the greatest thing in the world either.
Yogesh Ramadas working very quickly.
I
Oh, we have a
suspect-
circle. Taiji Hao has circled an answer on the left board. Hard to read from back here. We'll get a word from the floor.
Looks quite complicated. I'm not sure. I mean, I suspect that some sort of complex exponentials would have had hope here. Judge is conferring.
1/4 natural log of absolute value of secant 2x plus tangent 2x plus 1/2.
Again, the secants and tangents abound,
natural log of
making the
1/4.
number of possible
That
equivalent
is an
forms.
ugly answer. It might be right, but it is not an
Certainly
elegant
not pretty.
answer. Boy, let's see.
Yes, that's correct.
They got it.
He got it.
Taiji Hao with 2 minutes and 11 seconds left on the clock. The first integral of the final round takes a 1-0 lead over Yogesh Ramadas.
Oh, they're taking
Yogesh
another
now
one.
cross-checking his work.
Yeah, they're equivalent because you bring the cosine over with the secant of the tangent.
Okay, so now we have the answer up on the board. They have it in a nicer looking form.
It's equivalent, and that's all that really
Yogesh
matters here.
agrees. Okay, so 1-0 in favor of the gentleman on the left, Taiji Hao.
Taiji's really come on here.
He really has. He didn't start out. You didn't get that impression.
Yeah, he beat Bobby, but it wasn't exactly a jaw-dropping performance, although he did win in convincing fashion. But now, after taking out Vijay Kumar, he is once again stepping up, and he's done quite well, getting that first problem in just less than 2 minutes.
Okay, let's see where this goes now. So they're waiting for the next integral. Looks like it'll be a medium. Well, yeah, a medium again.
They might have decided that that's how they want to play out these finals, since nobody has gotten an extreme so far.
I spoke too. Oh, yeah, we're gonna go with a medium. This looks eerily similar to the answer to a previous integral.
Yeah, earlier we had, I think it was e to the x times that. Taiji's writing very fast.
He is.
And I bet just hearing your opponent's chalk click against the board, it's got to play in your mind a little bit there.
Yogesh has simply written the problem.
Well, here you can have one.
Taiji has circled an answer 30 seconds into the contest.
Sine inverse of x plus square root of 1 minus x squared.
The simplifications can take longer than the actual integral sometimes. Let's see what the judges say. Of course, we don't know if this wins it for Taiji or not because we haven't heard whether we're sticking with the 3 integral format for the final round or not. Yogesh picks up a lot of enemy intelligence if it doesn't work out.
Yeah, he does.
I mean, he's just blatantly staring at it. I guess if you're in the finals, you do what you got to do.
Indeed.
They're still trying to compare. No word from the judges. They gave it to him.
It is correct. Or
Judges, is it correct? Oh, no.
Well,
pausing.
wait. Someone said it was correct.
We got one, it's correct. Then we got a, oh wait. It is correct. Wow.
They gave it to him. Okay, so
Taiji is coming
Taiji
out
now
here.
up 2-0, and it looks like we're going to go ahead because they haven't stepped away yet.
Yeah,
So Taiji takes a commanding 2-0 lead in the final round.
It
Took him
appears,
only 31 seconds to solve that second integral.
it appears the official answer could have been simplified, I think. And that's what the problem was. So yeah, again, you never know. And they are
Okay,
going down to an extreme.
They are going to
here.
the extreme. You kind of have to. I mean, you can't.
Exactly. After showing some extremes earlier, you have to put at least an extreme
Okay,
here.
now, remember, it is first to 3, so this could make it for you. Well, if no one's got
Taiji with seemingly a commanding 2-0 lead.
And here's the integral.
Whew.
My goodness, a definite integral from 0 to pi.
We
That's
have
21 over 2x as the angle on the numerator.
We have x over 2 on the bottom. Oh, yes, I remember how this plays out. This is a very interesting problem. Simply substituting x equal to 2u, and dx would be 2 there. And then you'll get sine of 21u over sine of u, which is, well, what it really comes out to is it's sine of some odd number times x over sine of x. And from 0, well, in this case it's 0 to pi because of the substitution. I believe it would be from 0 to pi over 2 once with in the u form. And, well, the general problem, sine of nx over sine of x, that's a problem that really is just complex exponentials. Sine of nx over sine of x, well, sine of nx is going to be e to the inx minus e to the negative inx over 2I, and sine of x is going to be e to the ix minus e to the negative ix over 2I. The 2i's will go away. You'll basically get something of the form a to the n minus b to the n over a minus b. And now a to the n minus b to the n, the factorization of that, for odd n is going to be a minus b times a to the n minus 1 plus a to the n minus 2b, and it will keep going like that with the exponents of a going down and the exponents of b going up. And since it's from 0 to pi, you will be able to evaluate that. But this is a tough problem. To have never seen something like this before, and the fact that they're going to deal with the fraction in the signs at all just makes it even more difficult. I will be very surprised and extremely impressed if someone gets this problem. But again, sine or cosine of something over sine or cosine of something, if it's just like that and if it's got a reasonable set of limits, complex exponentials is a very good bet, simply because sine of nx will come out to something like a to the n minus b to the n, and sine of x is going to be a minus b, and many things will cancel out when that happens.
I'm looking for signs of substitutions they've done, but
Yeah, it really doesn't look like.
Not sure they've gotten that track at all.
Certainly x equal to 2u is somewhat of an arbitrary substitution. You can do it or you cannot do it. All it really does is make the thing inside the sign a little less ugly and it sticks like a 2 somewhere. It's not the biggest deal. It won't affect the answer significantly. And in this case, I believe the answer comes out to 0, in which case it won't affect the answer at all. It might be pi, though. I could be wrong.
So 2 and a bit remain. This is the first extreme problem that we've seen in the final round. Taiji Hao on the left with a 2-0 lead. His next correct answer makes him the MIT Grand Integrator for 2006. Needless to say, a coveted title on the campus.
Certainly something you can bring home to mom and dad.
Absolutely. Not to mention the various prizes we have for the winner.
And the prizes aren't just little insignificant things. They will be worth a fair amount. Doesn't look like either guy has too much. Yogesh seems to be grasping hopefully at something, whereas Taiji is just standing there and staring. Now the thing that I'm eager to see is if one of the two guys just goes out and guesses, because the answer is pretty simple. I'm almost certain of it. But so far, guessing really hasn't worked out. Every time someone has guessed, the answer's been far more complicated than I thought. So hopefully that prevents just a blatant, outright guess from happening, because I wouldn't like to see it end like that necessarily. Although it would be.
If Taiji writes 0 and it's right, and he just keeps his mouth shut.
True.
It could look very impressive.
He could.
What you have to do at this point to pull that off is step back from the board and just think. And wait until there's about 3 seconds left, and then go ahead and write it down.
With time winding down, it's almost a chess match between which of the two guys might write down an answer first. Because, well, if you write down an answer first, there is going to be a pause at least. And you might just give your opponent the idea needed to guess their own answer that turns out to be right.
That's true. Counter with the pi.
Yeah, exactly. It's very possible both of these guys have thought, well, it's probably going to be like 0 pi over 2 or pi or something like that. And my opponent puts down one thing, and it's wrong. Well, they've really just eliminated my possible options. But it doesn't look like
5 seconds. I don't think they're going to do it.
Doesn't look like either guy is going to do it.
Ooh, he moved to the board. Nope, nothing. Okay, we'll let
And the
this
answer is
expire.
pi.
It is pi.
Both guys standing there a little dumbfounded,
There's
probably thinking I could have guessed that.
There is an elegance to this.
To the madness in a sense.
All right, so still 2-0 in favor of Taiji Hao. He's on your left.
Going back to a medium.
Yogesh Ramadas on your right. 4 minutes on the clock. This is a medium integral.
Taiji comes out firing, so does Yogesh.
Taiji Hao. I'm sorry, go ahead.
Excuse me, both guys did come out firing. Both guys are still going. A minute has passed. Yogesh has stopped here, taking a look. Taiji is also going over his work a bit. Now Yogesh has started up again.
Taiji Hao has circled an answer.
Taiji
It's
Hao.
not small, but with 2 minutes and 43 seconds left, he's circled an answer.
This could be it.
He's on the left. He's looking to win. He's going to have to talk through it.
2/5, 10x minus 5 to the 5 halves, plus 10/3, 10x minus 5 to the 3 halves.
Might be easier just to copy it over. I'll copy it over. Yeah.
Ross Lippert's going to take the chalk and see what he thinks.
Yogesh is standing there, half wondering if he's done, half wondering if he's going to be able to glean some sort of information and make a comeback of sorts.
Well, the simplification rule went right out the window from round 1.
Yeah, it
A
really
lot of
did.
lenience here, and
It was-
that seems appropriate.
It does seem fair. It was put in it with the hope that, you know, things would be simplified at least somewhat reasonably. But at the same time, that really isn't the purpose of this competition. And in many cases, so the answers that really looked a lot uglier really were arguably simplified in their own form,
Looks
simply
like
because
he's
they
gonna
used
get
different
it.
functions. Still a lot of murmuring.
I thought a judge said it looked right, but they're still conferring.
Obviously, they'll be going over this one again.
He's
It's
got it.
correct.
He's
Tai
got
Ji
it.
Hao is the winner.
Taiji Hao, the 2006 champion of the MIT Integration B. Yogesh Ramadas, the runner-up in second place.
The second runner-up and the champion.
And we'll also bring up Vijay Kumar in third place for the awards ceremony.
What a performance.
Looking for Vijay Kumar.
I told him not to go, but he's like, I'm going to throw it.
I don't think Vijay Kumar is here.
He may have left.
He's here before we leave.
So Taiji Hao in the red with the khaki pants takes the victory. And we'll go down to the floor for the award presentation.
You know, like in the Olympics. You know, you're on that side and you're on that side. Okay. All right, to our second runner-up, we have a gift certificate to Christina's Ice Cream. To our runner-up, we have a gift certificate to Anna's Taqueria. And to our champion, we have a gift certificate to Amazon.com, plus
There's a special prize. Ross Lippert went to get the special prize.
And it's a hat.
this marvelous
That's
Taiji Hao, the grand integrator at MIT.
I believe he was only a sophomore, correct?
Thank you for participating and thank you all for coming.
That'll do it for us. This has been a presentation of MIT Sportcast in collaboration with the MIT Athletics Department and the Department of Mathematics here at MIT. Thanks again to the Student Information Processing Board for their support, to IS&T for their early support in this project. Thanks also to all the volunteers who helped put this production together. We're an all-volunteer operation. To learn more, visit sportcast.mit.edu. That's sportcast.mit.edu in your web browser, and learn more about what we do and come join us. We hope you enjoyed this presentation, and we hope you enjoy future games that we broadcast from Rockwell Cage, MIT basketball, and other sports in the spring. For Albert Nee, I'm Matt DeBurgalis. Have a pleasant evening.